Hello, guys. Welcome to this community live session. And today we are going to be talking about a very interesting and a very relevant topic, especially in today's times where all of us are very, very interested in learning about generative AI. So, let me share my screen and let me give you a quick intuition of what we are going to do today. So the topic that we are going to talk about is called as RAG, but it's not just our plain vanilla RAG, but rather we are going to talk about a very special variety of RAG, which is a graph RAG. Okay, so I hope all of you must have heard the term RAG sometime or the others. We have done few community sessions on RAG also. So today we are not going to do a deep dive on what is RAG and build a RAG project, but we are going to focus more on a variety of RAG, which is graph RAG. So let me lay down the agenda for today. We will do a quick recap of RAG. We'll not go into um, a deep discussion of RAG, but I'll assume that you must have heard about RAG somewhere, or at least you know on a high level basis that what RAG is. So we will talk about what is RAG, okay, and we'll talk about some limitations of RAG, okay, and we will see how a graph RAG comes into picture. So what, first of all, what is a graph? Or you must have heard the term knowledge graph. So we'll talk about what is knowledge graph, and then we'll talk about how do we build a retrieval on a knowledge graph. What are the major principles? And this session is going to be 2 hours long. So we're not going to do a deep dive on any of the topic, but we will understand the landscape and we will try to apply it and try to see what kind of a problem can be solved using this technique. Okay, so we'll talk about retrieval on a knowledge graph, and then we will try to build a simple project. Okay, the idea of the project is very simple, but we will try to do it end to end. So we will build all the we'll build it in an end to end manner with all the services and everything. So code and notes and everything that we are going to talk about today will be made available to you. Don't worry about that. And the outcome of today's session, which I want from all of you to tell me after the end of the session, is that you should have a very, very friendly intuition of what are the limitations of a typical RAG, what are the solutions of those limitations, and out of those solutions, where does a graph fit in, what exact problem does it solve, and how do you create a knowledge graph, how do you look at a knowledge graph, what are the key components of a knowledge graph, how do we do retrieval on a knowledge graph, right? And then how can we bring all of these ideas together to build a simple project that you can probably put on your resume. So this is the whole idea, and you will find that after learning this technique you can add another feather into your uh, quiver of knowledge about agentic AI or generative AI techniques. Okay, so that is our intent. That is our agenda. That is our intention from today's discussion. This is is it the fresh learning on RAG? No, this is not a fresh learning on RAG. That's what I said. Okay, so we'll just spend 10 minutes on what is RAG, a definition, but we are going to focus more on the limitations of RAG and advanced. What are the advanced RAG techniques? And out of those techniques, we are not going to learn about all of them, but we are going to learn about a specific one, which is the graph based technique. Okay. So, limitations of RAG is not this, but we want to talk about advanced techniques. Now, these are not advanced. I don't like to use the word advanced, but chalo rehne do. I want to say production or scaling related techniques, but okay, limitations of RAG, advanced techniques. Let me keep it till here. Okay, so we will try to cover this much in the first half, maybe in 1 hour, and then we'll try to spend 1 hour on these two techniques. And I want to add one more thing, which is if we are talking about knowledge graphs, then we need to talk about a knowledge graph database also. So we'll also learn about the most popular graph database, which will be Neo4j. Introduction to a graph DB, which is there are a lot of them, but the most popular one these days, which is being used, is Neo4j, and we'll do introduction to this also, and Cipher query language. This also we'll learn. Okay, so let us get started. Ashish is asking what is self rag. Self rag, पता नहीं यार, मैंने तो सुना नहीं. देख के बताऊंगा. Okay, so let us get started. So first thing is, what is a RAG system? What is the problem of a RAG. So can someone tell me quickly if you guys know about RAG already? If the answer is a majority yes, then I will keep it just 2 or 3 minutes. Otherwise, we can spend maybe 10 or 15 minutes on it. So first of all, what is a RAG? And when I talk about anything, when I say what is RAG, you can structure your answer around what is the problem that it solves. So if you can tell me the problem that it solves, then we know what it is. Okay. So we can say that a RAG solves the problem of LLM having limitations of LLM. This I have discussed in a separate community session. So if you want a detailed discussion on this, you can watch some other lectures. If you have signed up for this course, then you will find there's a section called Introduction to RAG. There are maybe 2 or 3 lectures where I have explained in depth about what RAG is. Okay, so RAG actually stands for Retrieval Augmented Generation. So this is a solution to a problem of a LLM having some limitations, like LLM has a knowledge cutoff. What does it mean, knowledge cutoff? It means that LLMs are trained and they are trained up till a particular date, and it has all the knowledge of all the data, all the text, all the article, all the news that was fed to that LLM during training up till that date. So maybe the LLM that I'm using today was trained in September 2025. So it has all the documents that was provided to it while training in September 2025. So if I am asking it about anything that has happened after that, the LLM does not know. So either it is going to say that it does not know, or it is going to hallucinate and it is going to make up something depending on how it is tuned. Okay. So that is one problem, that LLM cannot give you recent information. The second is that it is trained on public data, trained on public data. Okay. So if it is trained on public data, then it does not have any information about your proprietary data of your, if you want to create a retrieval system based on your company's internal documents or your personal documents or some documents that has come into light after the model was trained. So LLM does not know anything about it. If you want the LLM to respond on some documents which are dynamic in nature, for example, your product specifications or your internal memos or your company policies, which are constantly changing. So that also LLM does not know. Either it has seen a previous version of that while training if it was public data, but now the document has changed and LLM does not know anything about it. Okay. The third is that we need to ground LLM responses. What is the meaning of grounding LLM responses? It means that we need the LLM to respond on the basis of some document. Okay. I want, say for example, if you go to Zomato and you are trying to ask Zomato about some refund policies, so the chatbot, whatever chatbot is responding, it is not a general LLM. Of course, it is the OpenAI one, but it is responding on the basis of some documents that are backing it, and it cannot go beyond that. It cannot say anything beyond that. So that can be achieved using RAG also. It can be achieved using prompt engineering also. Okay. So these are some of the limitations, and there are more, but these are the most common ones. You can say that LLM also hallucinates. So ground LLM responses, I can say that this is a response to LLM hallucination. Okay. All of you must have experienced a LLM hallucination, which is basically when a LLM makes up random things to give you response. Some of them are also factually incorrect. So what are the possible solutions to these limitations? I've talked about limitations, but what are possible solutions? Some of the solutions I've already mentioned. The possible solutions, the first one is prompt engineering. What is prompt engineering? Engineering word, I don't like the word engineering here. I mean, there is no engineering as such, but that is a prompt. That is the uh, that is the most common phrase that you will hear, which is prompt engineering, which is basically changing your prompt or changing your system prompt and adding some instructions there as to what the LLM should do or should not do. Okay. For example, LLM should not use a particular phrase in responding, or LLM should not use any cuss words. LLM should not respond to any comment, any prompts which are uh, uh, which are based in violence or self harm or any kind of national threat. Right. So LLM will have those kind of prompts or guardrails that if a user is talking about so and so, then don't respond. So prompt engineering you must have all done, which is basically tweaking your prompt to say that okay, talk like this or talk like in the tone of maybe Hulk. I used to do that a lot when ChatGPT used to come. I used to, in my demonstrations when ChatGPT was very new, I used to write this prompt that whatever I ask, you should respond in the tone of Hulk, or talk like Darth Vader from Star Wars. So something like that. That is prompt engineering. So that is a very, very common first thing that you're going to do whenever your LLM is not doing what it is supposed to do. Okay. The second thing is fine tuning. What is fine tuning? Fine tuning means modifying the LLM itself. Okay. So prompt engineering is basically instructions to the LLM, but fine tuning is changing the model itself. It's a different area of study at altogether. We'll discuss about fine tuning in our detailed generative AI discussions. But fine tuning means it takes a lot of effort, it takes a lot of time, and you take a huge model. Usually, you will not be able to do it on your own, but you will have a huge model and you are going to tweak the parameters of the model. So, you know how a LLM is trained. High level LLM is given a lot of documents and it runs, it understands some patterns in those documents and it learns to basically predict the next word in your prompt. Okay. LLMs are nothing but they are next word predictors, fancy next word predictors. So you give it a prompt, it learns to predict the next word and then the next word and then the next word, and it does that until you get a response. Okay. So all of that happens based on some parameters that the model has learned. If you have a little bit of understanding of machine learning, you will know what these parameters mean. Or you can say these are basically huge bunch of numbers that contain the semantic understanding of phrases and words and etc. So we can tweak the LLM itself and we can do a fine tuning of that, and that can help us make the LLM behave the way we want it to behave. Okay, that is one solution. Another solution is also, one more solution is there, which is called as pre-training, but let us just keep it at that, which is fine tuning. And then we are having some solution like a RAG based solution. Okay, so what are the problems in fine tuning? Problem in fine tuning is that it is expensive and it is time taking. RAG and fine tuning cannot be done all the time. So if your document is constantly changing, so you cannot keep constantly fine tuning your model. So fine tuning happens when something fundamental in the model you want to change. Okay, but RAG is something that will allow the model to constantly be grounded based on some knowledge source. So this, we can say that this is ground the model response based on a knowledge source. Okay, I hope you guys already know these things. Now within RAG also, now if I talk, we want to zoom into this RAG because that is our area of study. Now within this RAG also, there are some limitations. Okay, there are not some limitations, there are a lot of limitations in a naive RAG. So if we zoom into this RAG part and if we talk about some limitations, and there are a lot of limitations, or a lot of, I will not say limitations, but I want to say challenges in RAG which you need to know about. And then we will see what are some of these challenges which we are going to solve using our discussion today. Okay, so there are a lot of challenges. I don't want to list them all, but some of them is that about problems, irrelevant retrieval based challenges. What is retrieval based challenges? Retrieval based challenges, and then I have model evaluation. How do you evaluate a model? Okay, so there are a lot of techniques to say that whether our model is working correctly or not. Okay, and then then there is guardrails in a RAG system, and then I want to have scaling and latency based issues. Okay, so these are some of the challenges in a RAG based solution. And I will give you a small flow of how RAG works in case you have never heard about RAG. I'm constantly saying RAG, but maybe you have not, you don't know about it. So I will give you a small overview. And there is one, within these challenges, there is one challenge which I want to further zoom in, which is our retrieval based challenge. Okay, in this retrieval based challenge further, I want to say that there is a very common problem in within retrieval based challenges that happens when your database, or when your data is, or I can say data is relationship centric. What do I mean by relationship centric or relationship heavy? I'm using my own terms here, relationship heavy. What, I don't know if you guys must have seen it, heard it somewhere else or not. But what do I mean by that? Once I explain it to you, you will feel a little bit comfortable with it. Okay, so it is possible that you have some data about some factual information. Okay, maybe some company policy. If suppose you are working on some company policy document, or say, let me first talk about typical RAG pipeline, and then I will say how this retrieval based challenge, or when data is relationship heavy, what it actually means. So what happens in a typical RAG based pipeline? If I talk about a normal LLM query, okay, you have this LLM, okay, and you give a query and the LLM gives a response. This is our normal generation process. Okay. Now this LLM has um, some limitations. I told you these are the limitations, and I want this LLM to respond to some queries which are about some specific document. Say I have a policy, I have a folder in my Google Drive which is having a lot of policy documents. Okay, maybe some HR policy documents. So there are a lot of documents on maybe hybrid work. There are some policies on compensation. There are policies on maternity leave. There are policies on employee attendance, or there are policies about reimbursement of phone bills, or there are policies about on-site, off-site, travel, whatever. Okay, so these are some of the policies, and maybe a user wants to ask a question about what is the policy on reimbursing of my phone bill or my Wi-Fi bill. Maybe the company wants to sponsor Wi-Fi bill for the people who are working from home. So there is a question, and this LLM does not know about it. Okay, so this is where RAG comes into picture. So a RAG pipeline is when I give a LLM a query. Okay, I have LLM a query. I give the query, and the LLM can go and ask this document. Okay, LLM can go and ask this document about the query, like a open book exam. I often give that example that RAG is nothing but an open book exam. When you go for an open book exam, you get the question, but you are allowed to cheat, or you are allowed to refer some books. So you will go to the book and you will go to the chapter which is most relevant to the query, and you will read a few paragraphs, and then you will use your intelligence and the question alongside, and then you will generate a response. Okay, so then you will get a response. So when the LLM is going to ask this knowledge base, इसको मैं हटा देता हूँ HR को, and I will just call this as my knowledge base. I hope all of you know, or if you don't know, you will have to watch my previous discussion on how exactly this happens. But LLM is going to refer, in very simple words, LLM is going to refer, or LLM is going to ask this knowledge base. Okay, I'm simplifying it a lot here, and this knowledge base is going to return some context. Okay, so basically LLM is not going to do that. We are going to do that. So let me draw it properly. I'll say that this query actually will go to the knowledge base. Okay, and there is a system that will ask the knowledge base that which document is the closest to the query. So maybe this document is about work from home, and this document is about maternity leaves, and this document is about harassment at work, and this document is about reimbursement of phone bills. Okay, so whatever query the question user is asking, the answer is in this document. Okay, so this knowledge base is going to return all the content of this document to the LLM. So now LLM has the query and it has the context, and it can look at the query, it has the context, and it can use its own general intelligence, and it can frame a response and give it to the user. Okay, so this entire work, this entire thing, this is, I've made a very spoiled the whole diagram. This whole thing is called as a RAG pipeline, a typical RAG pipeline. So if you look at high level in this RAG pipeline, there are two major processes. There are two major processes that are happening. The first process is the retrieval, and the second process is generation. Okay, this is something that you have to keep in mind. Retrieval and generation. So retrieval is the part of the RAG where the question is given to the knowledge base, and the knowledge base returns some context. Okay, and generation is the part where the LLM is looking at the query and context, and it is generating the response. Now, if a RAG pipeline is not performing very well, this is a typical RAG, then it is possible that either this is faulty or this is faulty. And we are going to address this retrieval part. Now, if retrieval part is faulty, it can be faulty for many reasons. It can be faulty for many reasons, but we are going to address one particular reason in today's discussion, which is that if the document is having a lot of relations. So the example that I gave you, in this example, whatever query has been given, that query can be found, the answer to the query can be found in a particular document. The user is asking for Wi-Fi reimbursement, so we will look for the word Wi-Fi, or we'll look for the word reimbursement, and which document contains these words. Whichever document will contain that word, that document will be given back. How this happens? Typically the retrieval, the process happens using semantic search and keyword search. Typical retrieval process. Typical retrieval happens using semantic search and keyword search. Okay, semantic search happens using embeddings, and keyword search happens using algorithms like BM25 and all of that. And you can mix them also. You can say hybrid approach. Now, hybrid approach can contain other elements also, but typically these are the two things that are used. I'm talking about a typical RAG. Okay. Now, where does graph come into picture? We have discussed so much, but where does graph come into picture? Graph comes into picture when we are dealing with a document that is having facts, but those facts are also related to each other. Okay. Or there are the relationship component in the document is more dominating or equally dominating than the facts themselves. For example, I can say that if I'm having a document about, today we are going to talk about maybe a Bollywood document. So maybe there is a Bollywood uh, knowledge repository where all the information about all the Bollywood movies are there. So who is Shah Rukh Khan, when he was born, what type of movies he has done, and who is Karan Johar and what type of movies he has done. And Shah Rukh Khan and Karan Johar are friends with each other. And what was the script of Dhurandhar? Who was the director of Dhurandhar? What award he got? Who gave the music? Who were the actors? Who were the actors who auditioned but they did not get the role? So you know, a lot of Bollywood gossip is there. Okay, that you will read in newspapers. So you will see all of these are having a lot of relationship with each other. There's a lot of there are a lot of entities, and those are very very connected with each other. So if you ask a question that the director, what are who is the wife of director? Suppose you're asking this question: who is the wife of director of the best movie in 2026? सपोज इस टाइप का क्वेश्चन आएगा, या इसको थोड़ा सा मैं सिंपल कर देता हूँ, डायरेक्टर ऑफ धुरंधर, और आई विल से लाइक दिस: हु इज द वाइफ ऑफ डायरेक्टर ऑफ द फेमस मूवी रणवीर सिंह एक्टेड इन? Suppose this is the question. Okay. So what is going to happen here is that if you do a semantic search on this type of a question, or if you do a keyword search on this type of a question, what is going to happen? You are going to be looking at some phrases like director, और आप देखोगे कि डायरेक्टर से सिमिलर कौन सा डॉक्यूमेंट्स है इसके अंदर, और यू विल सी मे बी सम डॉक्यूमेंट्स अराउंड रणवीर सिंह. Okay, and you will find some chunks. Okay, you will find some words around wife, you will find some documents, but whatever documents you find, they may or may not give you the answer to this question. आपको वाइफ से रिलेटेड सारे डॉक्यूमेंट्स मिल जाएगा, आपको डायरेक्टर से रिलेटेड डॉक्यूमेंट्स मिल जाएगा, यू विल गेट डॉक्यूमेंट्स अबाउट रणवीर सिंह, बट द क्वेश्चन इज having a lot of relationship within itself. Okay, so it is talking about a director wife, but whose wife? The wife of the director. Okay, who is this director? The director of a movie. Which movie? The movie in which Ranveer Singh has acted. Okay, so I need to find out which are the movies Ranveer Singh has acted. Okay, out of that we need to see which is the most famous movie. Okay, may or may not, we may not be able to decide which is the famous movie, but at least I can get movie number 1, movie number 2, movie number 3, and movie number 4. Okay, and out of all those 4 movies, I need, maybe some way I need to find which is famous, or we need to find whether we are having information about the director or not, and we will get some directors, like this is maybe director 1, director 2, director 3, director 4, and out of those directors we need to find out who is the wife of this director, who is the wife of this director, who is the wife of this director, who is the wife of this director. So we will have maybe 4 candidates or 4 possible responses to this question, and maybe there will be something more like most famous. So every movie will have its some metadata of what was the collection, or whether it was there's more data about it. Somewhere the LLM is going to figure out which is the famous or which is the most money making, and from there we need to find out who is the wife, and then we are going to return that answer. So you see, this is not a typical RAG flow. This is not a typical RAG flow where your semantic search and keyword search is going to work. Okay, so this type of query or this type of data where we are having a lot of relationship, that is where a graph based approach is going to come in handy. Okay, graph is something that you're also learning in your data structures algorithms. You don't have to, means the idea is similar. So if you know those things, you will be able to relate here, or you will be a little bit more comfortable here. Otherwise, I'm going to discuss it completely from scratch. Okay, so this is where a graph based approach is going to work. This type of questions are also called as multi-hop reasoning. Multi-hop reasoning. Okay, you have to go from movie, you have to go from Ranveer Singh to movie, from movie you have to go to director, from director you have to go to wife. Okay, or the question can be that which is the most famous movie of the wife of the director of the famous movie Ranveer Singh acted. ऐसा करके question हो सकता है. So I mean, I'm exaggerating a lot, ऐसा नहीं होगा, but you will see like questions like who was the CEO of the startup that competed with a company that that Reliance was trying to acquire. This type of question. ठीक है, तो इस टाइप का जो क्वेश्चन है जिसमें बहुत ज्यादा रिलेशनशिप है विद इन द क्वेश्चन, this cannot be solved by using a typical flow. So this is where we have to find a different approach. Now I am saying graph based approach, but what does graph based approach means? So if you'll see about graph based approach, there are three main entities in a graph based approach, or I will call it knowledge graphs. In a graph based approach or knowledge graphs, kitna time ho raha hai? 7:30. Okay, we'll quickly finish and then we will go to new 4J within 15 to 20 minutes. I don't want to exceed the time. Okay, so we are talking about this graph based approach. There are three major things in a graph based approach. The first thing is entities. Okay, the second thing is the relationship between the entities. Okay, so entities will also be called as nodes. You know, a graph is nothing but nodes and edges, or vertices and edges. Okay, so here also graph is that we are going to have some entities and we are going to have some relationship, or I'm going to call it edges. And the third is properties. Okay, so properties, or I can say this is metadata. Metadata nahi bolte, properties bolte. Okay, so what does this mean? If suppose I'm having a node, like I'm having a node called Shahrukh Khan or Ranveer Singh, let me say. Okay, so this is a node for Ranveer Singh. So actually here I will have a node, and this node will be of some type. Maybe I will say this node is of the type actor. Okay, and inside this I'm having some metadata, and inside the metadata I'm having, maybe I will say name is Ranveer and age is maybe 40, and I will have maybe city or date of birth or something, some information, whatever I can get it from his Wikipedia page or whatever the knowledge source is there. Okay, so this is one node, and I can connect it to another node. Okay, another node, and this is another node which is of a movie. So I'll say that this node is of the type movie. This is of the type is nothing but it is just a metadata only, you can think. This is a node, this is also node. So this node will also have some properties. I told you that I'm going to have nodes, and I'm going to have relationship, and I'm going to have properties. So this is also going to have some properties, like for example, name of the movie is going to be tell me a movie of Ranveer Singh. धुरंधर डाल देते हैं, ठीक है. Okay, and maybe I will have some information about the movie, like box office collection, or when it was released. Okay, or few more items, whatever you want to have here. Okay, and what I am having here as a edge here, this edge is the relationship. So Ranveer and the movie Dhurandhar, these are two nodes. And how are they connected with each other? How are they connected? There is going to be some property to this also. So I'm going to say I'm going to have a verb here, like acted in. Okay, and then I can have maybe another node here, and this also can have some properties, by the way. So here also I can have some properties, and these properties can be acted in as character, and character can be Hamza. Okay, and here there can be more items here. Okay, like how much he was paid, or what was his alias, or what was whether he was the main hero or not. You can have a lot of features. Okay, so this is a simple graph that I've created, but now this graph can have more things. For example, this movie Dhurandhar, I can have one more relationship here, and I can have one relationship here, and I can say produced by, and here I will have name of the producer and all of those things. Okay, and then maybe this is also of the type, this is of the type maybe producer. Okay, and this is again having maybe some connection with some other person, like producer is having some connection to maybe kya example do, maybe director. Okay, so here I'm also having the director of the movie. Okay, now this director of the movie can also be producer and director, maybe they are friends, so I can have here like friends. And this director can also be connected to the movie here, which can be like this connection, which is directed by. Okay, and Ranveer Singh and director can be maybe brothers. Okay, so here I can say he's a brother. Okay, so you see I have created a simple graph. So this type of graph is only called as a knowledge graph. This is very knowledge graph is not just only for RAG systems. It is a separate area of study in itself, and it has lot of application in lot of different things. But today we are discussing about RAG, so I'm talking about it in the context of this. But this kind of entity relationship and properties, if you create, then it solves a lot of other problems also. Pradeep Goyal is asking custom chatbot using some internal documents. Yes, custom chatbot using internal documents is a RAG based application. Okay. So this is our knowledge graph. Now, how is it going to solve our problem, which I mentioned here? Who is the wife of director of the famous movie Ranveer Singh acted in? Now, if in some way I can create embeddings of these nodes, if I can create embeddings of these nodes, then what will happen is that I can do my retrieval in a different way. I can do my retrieval in a better way. So I can say my retrieval process with graph. So it is not a replacement of the traditional RAG. Okay, what I'm suggesting here is not supposed to completely replace this process. This process will be there. This process is always going to be there, that you give a query and you are going to go to the knowledge base, and knowledge base is going to give you the context. The only difference is that in the typical RAG, you are going to take this knowledge base and you are going to create chunkings out of those, then you are going to create embeddings out of those, then you are going to create embedding of the query, you are going to match the query with all the embeddings, you are going to find the correct context, and then maybe you are going to do some kind of re-ranking, and in the end you are going to get the context. That is a typical flow. But when it comes to graph RAG, okay, when it comes to graph RAG, the process is little bit different. Okay, so here I will probably make a comparison so that you completely understand. Is everyone with me so far able to understand? Please tell me in the chat yes or no. समझ में आ रहा है? Okay. I will say typical RAG flow. Okay. Typical RAG flow is what? Typical RAG flow is that you have a query. Okay. So query, and you have a knowledge base. You have maybe your documents. For these documents, you create chunking. You do chunking, and after chunking, you do embedding. Okay. So you will create your embeddings. Okay. Now, when you get the query, you are going to give this query to the LLM. But before giving it to the LLM, you're also going to give it to your embeddings. And here you are going to do a vector search or some other search, whatever search you want. And this is going to, यहाँ पे एक और step आएगा, where you will create embeddings of the query also. Okay. And this query embedding, you will compare with all these embeddings, and you are going to get some retrieval, or you are going to get some context. Okay. ये retrieval के बीच में you can also do create embedding using Gensim, for example. You can create embedding in whichever way you want. Embedding is basically your vector representation of your text, which can contain the semantic similarity. You can use Gensim, but nowadays the most popular way to do it is using LLMs. Okay, so Gensim behind the scenes, I don't remember what it uses, but nowadays you will not find Gensim as the you'll not find it typically when you are reading other people's code. But it's not that you cannot you cannot work with it. You can work with it, but that is not the common choice that you will see. Mostly you will see people using some kind of LLM or some kind of sentence transformers from Hugging Face, or they will use APIs and they are going to access it using from OpenAI or Gemini or things like that. Okay, so I'll show you how it works. We'll put that in our project also. I'll show you exactly how it works. Okay, so we are having this context, and within this context, before getting this context, this process will be called as retrieval, or this process is not called retrieval. This entire flow is called as retrieval. This entire flow will be called as retrieval process. I hope you know it. I don't have to draw too much. I want to move fast. Okay, so यहाँ पे ये vector store हो गया. This is our vector store. Vector store, like you can use Fice, or you can use Pinecone, BB8, ChromaDB, whatever you Postgres, PG vector, whatever you want to use, you can use. But this is basically a vector store. This is the database that is storing the vectors, and the job is to take this embedding and compare with all the vectors, get the context. Now this context will also go to the LLM, and once the LLM has the query and the context, now the LLM is going to give us the response. Okay, so this is a typical RAG flow. इस पूरे को मैं let me take it to the new page so that you will be able to follow. Now, what is the difference with graph? That is something I want to show. Okay, so इस process में क्या हो रहा है? इस process में we are using semantic similarity and we are using vector search. Now, the problem in this approach is that we are doing vector search in this embedding space. Okay, this embedding space is not capturing the relationships. It is only capturing the semantic meaning. Okay, so it knows about the movie Dhurandhar. It knows about the director Ranveer Singh, but it does not really relate that Ranveer Singh has acted in Dhurandhar unless that statement is directly there in the vector store in some chunk. किसी chunk में ये लिखा रहेगा कि Ranveer Singh acted in the movie, जो रहेगा, ठीक है, लेकिन अब अगर उसमें मल्टी हॉप है, that you want to look for the movie that earned more than 500 crores, in which Ranveer Singh was the actor, in which the other actor was maybe some female actor ka information chahiye. So if there are a lot of like these hops, then semantic similarity is not going to work. So what we are going to do in our graph based flow, in our graph based flow, we are going to first create our knowledge graph. So we are going to have our documents. Okay, we are going to have some our documents, and typically these documents will be unstructured documents. Okay, so we'll do these unstructured documents, and from these unstructured documents we are going to extract entities. We are going to extract entities and relationships. Okay, so हमारे पास ये जो यहाँ पे मैंने ग्राफ बनाया, okay, this graph will not be given to us. Okay, this graph will not be given to us. We have to create this graph from where? Maybe from magazine articles or from IMDb stuff or movie plots or whatever. We will be having free text. From those free text, we need to understand that in that free text, who are the actors, which are the movie, who is the director, who is the producer. So you must have heard about entity extraction. You must have heard about entity extraction. If you are learned about NLP, or if you know about the Spacey library, you will know that even before LLM came, entity extraction was a thing. Okay, like example, you will see that NER is there in Spacey. Okay, or we have very often done it using pattern recognition in regex. For example, we all must have done this kind of things where we are having a lot of messages. From those messages we need to take out the OTP. ओके, सो वो पैटर्न रिकॉग्निशन के थ्रू हम लोग वो निकालते थे, या ईमेल निकालना है तो ईमेल के लिए रेगुलर एक्सप्रेशन लिखते थे कि something@something.com, या वेबसाइट निकालना तो वेबसाइट का पैटर्न लिखते थे कि https://something something.something.com. okay, this type of things we used to do, or we used to use some models which used to do named entity recognition in Spacey. कि इफ यू आर हैविंग अ टेक्स्ट, इट विल अंडरस्टैंड दैट कहीं पे करेंसी की बात हो रही है, कोई जियोपॉलिटिकल लोकेशन है, कोई सेलिब्रिटी है, कोई नेम है. ओके, सो इफ यू गिव इट अ टेक्स्ट लाइक राजीव went to Dubai for earning 10 lakh rupees, so it will extract that okay, there is a name person called Rajiv, there is a geographical location called Dubai, and there is currency of 10 lakh. These kind of things it is able to extract, but it is only able to extract the entity. It is not able to extract the relationships, okay, of how entities are related. Okay, so this is the important thing that we need to do on unstructured data so that we are able to get this graph data. So first we have to create this graph data. Okay, we need to have something on which we can query. So typical RAG mein we are having a vector store. Vector store is created by chunking the data, embedding the data, and we have a vector store. उस vector store के ऊपर हम लोग we do the query. But here that is not the case. We have to create a knowledge graph. In order to create a knowledge graph, we need to do entity extraction and we need to do relationship extraction. So you can figure out any way to do this, but typically we will do it using LLMs. ओके, हाउ LLMs को हम लोग बताएंगे कि एंटिटी की डेफिनेशन क्या है, और LLM को बताएंगे कि रिलेशनशिप की डेफिनेशन क्या है. LLM इज गोइंग टू एक्सट्रैक्ट दैट स्ट्रक्चर्ड इंफॉर्मेशन फ्रॉम the unstructured data. So we are going to have LLMs, plus we are going to use structured output feature. Do you guys know what is structured output feature in LLMs? Yes or no, please tell me. Or using pydantic schemas, we will define some schemas and we will ask the LLM to extract those schemas. Okay, pydantic schema or structured output means when we are asking a LLM to respond in a given format. ठीक है, सपोज आपका एक यूआई है, उस यूआई में आपको एक जोक दिखाना है. ठीक है, एक सपोज एक यूआई है. ठीक है, एक वेबसाइट आपने बनाया, उस वेबसाइट में एक पर्सन आएगा और वो एक टॉपिक लेगा, और जो आपका वेबसाइट है वो उस टॉपिक पे उसको एक जोक सुनाएगा. ओके, या ऐसा नहीं करते, ऐसा करते हैं कि आपका जो एलएलएम है वो केबीसी का गेम चला रहा है. ठीक है, तो केबीसी का जो गेम चला रहा है, हम जब भी एलएलएम से बात करेंगे तो एलएलएम को बोलेंगे कि एलएलएम मुझे केबीसी का नेक्स्ट क्वेश्चन दो. ओके, सो हाउ विल दैट क्वेश्चन बी? Okay, there has to be a template. There will be a question, then there will be 4 answers, A, B, C, and D. Okay, so whenever LLM is generating this, LLM always has to give a question, then LLM has to give 4 answers, and then LLM has to give the correct answer also, which will be shown by Amitabh Bachchan once the user has logged. है ना? तो correct answer we need. So we will need option A, B, C, and D, and then we will need the correct answer also. And we need few other things. For example, if the patient, if the participant says 50-50, then which 2 options we have to eliminate? Okay, so this is the complete format. So if you want to build this using LLM, then we need to inform LLM to give me response in this format only. देन ओनली माई यूआई कैन कंज्यूम इट। एलएलएम अपनी मर्जी से कभी 3 ऑप्शन दिया, कभी 4 ऑप्शन दिया, कभी करेक्ट आंसर दिया, कभी नहीं दिया, है ना। क्वेश्चन का भी कुछ फॉर्मेट होना चाहिए, क्वेश्चन इतने लेंथ का होना चाहिए, ऐसा नहीं कि 3 पैराग्राफ का क्वेश्चन दे दिया, राइट। सो इफ यू वांट टू जनरेट दिस यूजिंग एलएलएम, देन यू हैव टू फोर्स एलएलएम to generate something in a structured manner. Normally, we don't do that. When we are interacting with ChatGPT or Claude, we just write prompts and they give us a response. It is conversational. But when you want to integrate your LLMs into some application, that application is going to run only when there is something structured. All of you are part of the Fast API course. So how does the REST API and our backend works? When the server calls, the client responds, and when they respond in a specific format. They cannot respond on their own. उसका keys fixed है, उसका data type fixed है, उसमें क्या क्या constraints होगा वो fixed है. So similarly, there is a way in which LLMs can also respond in a structured manner. Okay, so we are going to use that feature of LLMs. This is what we typically use. आप अपनी मर्जी से आप कैसे भी entity और relationship extraction आप कर सकते हो, आप चाहे मर्जी खुद से बैठ के करो. But typically we will use LLMs, and we will use this LLMs structured output feature. And structured output feature में जब Python में बात करते हैं तो it is always you use Pydantic models, and you give that to the LLM and you say LLM that here is the document, here is the structure, and इस structure के हिसाब से मुझे entities और notes बना के दो. Which means I am going to tell LM that okay, you need to find for actors. Who are the actors? ठीक है, who are the directors? Who are the producers? What are the movies? Okay, and what are the relationships? So relationship can be acted in, directed in, produced, singing. Who are the music directors? So LLM will first find out all the entities कि ये actors है, ये actresses है, ये dancers है, ये music directors है, ये choreographers है. It will find all that, and then it will link कि इस मूवी का ये एक्टर था, इस मूवी का ये डायरेक्टर था, इस मूवी में ये कोरियोग्राफर था, इस मूवी का जो डायरेक्टर था उस डायरेक्टर का एक और दूसरा मूवी ये था. सो इट विल क्रिएट दोस चेन्स. Okay, this time first it will find all the notes. I will give you practical of this. I don't know how much time I will have. If you guys can extend, then we will have all that. So it will first create all the notes, different types of notes. So these are all the actors, maybe these are all the movies, and these are all the maybe singers, and then it will create the relationships. So it will create relationships like okay, this is connected to this, 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 this connected to this, ऐसे सब connected हो जाएगा. Okay, so you will get what is called as a knowledge graph. Okay, इस टाइप का एक ग्राफ बन जाएगा. अब ये ग्राफ जब बन गया हमारे पास, तो हमारे पास हमारा सोर्स आ गया. यू विल सी दैट वी आर अनस्ट्रक्चर्ड डॉक्यूमेंट्स, वी हैव एंटिटीज एंड रिलेशनशिप्स. वी विल क्रिएट अ नॉलेज ग्राफ. Once we have this knowledge graph, we are going to create embeddings on this. Embeddings. Okay, so we will create our, and normally इसमें कुछ indexing use होती है बहुत सारी, उसमें technicalities. I'm just going over all of that, how it works, but you can think of that I am going to take all the nodes, जितना भी ये nodes है, okay, ये सारे nodes का I will create embeddings and I will store it. So इस node का कुछ embedding हो गया, इस node का कुछ embedding हो गया, इस node का भी कुछ embedding हो गया, इस node का भी कुछ embedding हो गया. You can ask that, sir, how will you create embedding of a node? I can say that inside the node there is a JSON type of a structure, there is a dictionary type of a structure. उस dictionary का structure मुझे मालूम है पहले से, क्योंकि मैंने Pydantic schema उसका बनाया हुआ है. So I know what is the information about an actor, what are the fields, what is the information inside a movie, what are the fields. Based on that, I can create some text. I can create a text out of a node. So if suppose this is the node, इस नोड का मैं एक टेक्स्ट बना सकता हूं दैट रणवीर सिंह whose age is 40, who was born in Delhi, whose date of birth is so and so, lives in Mumbai. इस इंफॉर्मेशन को लेके मैं एक सेंटेंस बना सकता हूँ. उस सेंटेंस का मैं एक एम्बेडिंग बना के यहाँ पे स्टोर कर सकता हूँ. अब यहाँ पे स्टोर करो या किसी वेक्टर डेटाबेस में स्टोर करो, दैट इज अप टू यू. बट Neo4j, the database that we are going to use, is going to allow us to store these embeddings inside this node only, which is what we are going to do. But you need not store it here. You can store it in your typical, wherever you are storing in your normal RAG flow. Okay, so here in this vector store now, in a typical RAG flow, we were having documents. उस document का chunking करके, उसका embedding करके, we created this vector store. In a graph, what we are doing, we are having unstructured document. Out of those unstructured document, we are using entity and relationship. This is called as entity extraction process. This itself is a detailed subject of study. How do you do entity extraction? But for now, we'll assume that डॉक्यूमेंट था, एलएलएम था, एलएलएम को हमने डॉक्यूमेंट दे दिया और उसने हमें एंटिटीज और रिलेशनशिप निकाल के दे दिया. एंटिटीज एंड रिलेशनशिप्स को हमने एक नॉलेज ग्राफ में डाल दिया. नॉलेज ग्राफ यहाँ पे हमारा Neo4j, बेसिकली एक डेटाबेस ले लिया हमने. उस डेटाबेस के सारे नोड्स का हमने एम्बेडिंग्स बना के एक ग्राफ एम्बेडिंग्स टाइप का हमने स्ट्रक्चर बना लिया. ओके, एवरीवन इज क्लियर टिल हियर गाइस? एबल टू फॉलो? एम आई गोइंग टू फास्ट? टेल मी यस और नो इन द चैट. अप टिल हियर एवरीवन इज ओके? 1 घंटा हो गया, 1 घंटा हो रहा है. Okay, so once you have these embeddings, now what will happen? Now we will have the query. सेम इससे कंपेयर करो, ठीक है? पहले तो हमारे पास जो डेटा था, डॉक्यूमेंट्स था, यहाँ पे ये डॉक्यूमेंट्स था, इस डॉक्यूमेंट्स का चंकिंग किया, एम्बेडिंग किया, वेक्टर डेटाबेस बनाया, जब क्वेरी आया तो क्वेरी के एम्बेडिंग को इस वेक्टर से हमने कंपेयर किया और हमें कॉन्टेक्स्ट मिला। अब यहाँ पे देखो वही काम होने वाला है, ठीक है? वी विल हैव अ क्वेरी, इस क्वेरी का हम लोग एम्बेडिंग बनाएंगे। अगेन व्हेन आई से क्वेरी, there are some steps in between also, so we do query expansion, some engineering on the query itself to make the query better, but I'm skipping all those things. I'm giving you a high level overview. Those smaller details we can discuss later. Okay, so here we are going to have a query embedding. If you follow this process, then the code walkthrough when I give you, it will be very very easy for you to understand. Okay, I will do query embedding, and this query embedding will go and query on this thing. So it will find out in this graph database, I'm having all these different nodes. हर node का कुछ ना कुछ embedding है. Okay, every node is having some embedding. So I'm going to find out which nodes are the closest to my query embedding. So if the query is talking about Dhurandhar and Ranveer Singh and 2026, okay, I missed on Neo4j and nodes. I have not discussed anything about Neo4j. बस ये सोचो कि Neo4j हमारा knowledge डेटाबेस है जो हम लोग नॉलेज ग्राफ क्रिएट करने के लिए यूज करेंगे। अभी तक हमने Neo4j देखा नहीं, ठीक है? ऑल आई हैव सेड हियर टिल नाउ इज दैट वील हैव अनस्ट्रक्चर्ड डॉक्यूमेंट। अनस्ट्रक्चर्ड डॉक्यूमेंट से एंटिटी एक्सट्रैक्शन करेंगे, एंटिटी एक्सट्रैक्शन से एक नॉलेज डेटाबेस, ग्राफ डेटाबेस में डेटा डालेंगे, और उसमें जो भी नोड्स होंगे, ऑल फॉर ऑल द नोड्स आई एम गोइंग टू क्रिएट embeddings. Now when I will have the query, I will take the query, I will create the query embedding, and I will find out which are the nodes which are relevant to my query. So maybe this node is relevant because it is talking about Dhurandhar, and this node is talking about Ranveer Singh, and maybe this is the node which is talking about छोड़ो, दो ही नोड लेते हैं, ठीक है? तो these are the two nodes. Okay, so this is our vector search. So you see vector search was happening earlier also and now also, but vector search on what, that has changed. Okay, now what will happen? We are going to get some nodes from here. Okay, I will call it relevant nodes. Relevant nodes. But we have to do one thing, that we have found the relevant nodes, but we are also interested in the relationship of those nodes. So for example, I got one relevant node as Ranveer Singh. So Ranveer Singh will have some relevant connected nodes or its subgraph, I will say, or its neighbors. So Ranveer Singh का neighbors कौन होगा? Ranveer Singh के graph में Ranveer Singh will have one node which will be of Ranveer Singh's wife. Ranveer Singh has acted in some other movie, it will be that. Ranveer Singh has invested in some startup, it will be that. Ranveer Singh got Filmfare award, it will be that. Ranveer Singh is friend with someone, it will be that. So I will, once I know that Ranveer Singh is the center of my query, I will find out all the relevant nodes, connected nodes around Ranveer Singh. That also I will fetch. Okay, I know about Dhurandhar, so my query is talking about Dhurandhar, and I told you that the purpose of doing all of this is to extract relationships. Okay, till now we have done normal embedding on entities, but I don't just want entities, I also want the relationship of the entities. तो हमने relevant nodes निकाला, उस relevant nodes का neighbors भी we will get. Okay, so we will get this Dhurandhar movie, but I will have some relevant nodes of बार बार मैं relevant बोल रहा हूँ, connected nodes of this Dhurandhar movie, which will be maybe Dhurandhar was produced by somebody, Dhurandhar was criticized by somebody, Dhurandhar was blocked or censored by somebody, or Dhurandhar was criticized in Pakistan, so Pakistan is connected, or there will be a lot of different nodes connected to this. Okay, so we will first find using vector search which are the center point of which are the interesting nodes, and out of those interesting nodes I will get their neighbors. ठीक है, जैसे आप पुलिस इन्वेस्टिगेशन करते हो, अगर आप मूवीज में देखोगे कि जिसने चोरी किया उसको पकड़ते हैं और उसके घर वालों को भी पकड़ते हैं, घर वालों के पास कुछ एक्स्ट्रा जानकारी मिल जाएगा, ठीक है? सो we are going to do that. So we will do relevant nodes, and then for these relevant nodes I am going to do extract we will say subgraphs, extract subgraphs. Okay, now what do I have? I have my nodes filtered, or I will say relevant nodes plus subgraphs. Okay, plus relationships also. So we will take this and पूरा गंदा हो गया, एक मिनट रुको, this whole thing now query will go to the LLM. बहुत सॉरी, गंदा डायग्राम बनाया मैंने. Query will go to the LLM and this will go to the LLM. So this is our context. Okay, and then LLM will give the response. Okay, so if you think about it, क्या हो गया इसको, ये सॉफ्टवेयर भी अपना दम तोड़ दिया. चलो ठीक है, I hope you got it. So in a typical RAG flow, I want to summarize the whole thing before we move ahead. Okay, if you think about RAG pipeline, okay, it's always about a LLM taking a query and taking some context and generating a response. This is the high level thing. In a typical flow, the context is coming from a vector database which is made out of chunking the documents. In a graph database, the context is coming from a graph database built on top of a structured document. And from those graph documents, we are getting what? We are getting nodes and entities. So it is possible that my RAG can, in my RAG, the context can come from multiple sources. ऐसा नहीं है कि मुझे I have to create a graph only, or I want to create chunking embedding only. I can mix both of them. Okay, so that gives rise to agentic RAG. You can have an agentic RAG. Agentic RAG, which you will typically find, will have whatever we are going to learn today, or whatever we are learning today. All of that is going to be a tool. So agentic RAG, basically, if you talk about any agent, agent is nothing but a LLM which has memory, which has some tools, okay, which has maybe some session और memory एक ही बात हो गया, ये दोनों रखते हैं, ठीक है. और this if you combine, okay, then that is only what we call as an agent, okay. Or you can think of agent as a human being, LLM as the brain. So when you talk to the LLM, you can just talk to it. It cannot do anything. But when you give hands and legs to the LLM, then LLM can perform actions also. When it can perform actions, then it becomes agent, right? So you talk to ChatGPT, fine, but you talk to Claude Code. Claude Code is an agent. It can do things. Okay, you can say that, okay, my code is having this bug, please fix it, or you will give it a GitHub bug link. It can go to your GitHub. It can log in. So basically, it's what it is having tools. Okay, so it will have tools. It can use those tools and perform some actions. It will ask you that, do you want me to do this or not? So it will have agent. Now agent itself can have some sub agents, and agents can also have tools. Okay, so if I want an agentic RAGs, and then I can build something like where there is a query, okay, and then this query, this agentic RAG will decide from how best to answer this query. So sometimes it will say that, okay, my data can come from maybe a structured data which I have. So it will use a NL to SQL kind of a thing. It will think that, okay, no, data is more factual, so I can do a typical vector search. Okay, it will think that, okay, no, the query cannot be answered using these, then I can use maybe graph based retrieval. Okay, or it can think that, no, it will come from all three. So कुछ information वो structured data से ले लेगा, natural language को SQL query बनाएगा, SQL query को execute करेगा, Postgres से data निकाल लेगा, ठीक है. Then it can do a simple vector search also, or hybrid search also, or keyword search also, and then it can do a graph based search also. So it can get context from vector search also, graph based search also. All of them will return some answer to it, and it will give the answer response to the user. Okay, so graph based retrieval can be one part of a bigger agentic project. Okay, today we are not going to do it, but when we do our RAG in detail in our generative AI course, there definitely we are going to cover this project also. What is React agent? React is nothing but reason and act. Reason and act. तो यहाँ पे क्या हो रहा है? यहाँ पे reason and act ही तो हो रहा है. Here we are doing reasoning and acting only. The LLM is able to first break down the query, and it is internally doing some prompts to understand what is the best approach. So then it decides what is the best approach. According to that, it does all the tools. Okay, it's like human being. You will have a toolkit. Suppose I want to put a nail on the wall. Okay, so I will have a toolkit. First, when I analyze the task, that, okay, what is the task I want to do? Based on that, I will select, okay, which is the proper tool for me, and then I will use that tool to perform. Okay, every agent is not a React agent, but usually they are React agents. It is actually a pattern of a design pattern in agents. It's a separate discussion, but you can normally think an agent normally will have reasoning and acting. Okay, all agents need not react. All agents need not be. Some agents can be deterministic also. For example, a typical flow kind of a workflow kind of a thing, where they are not reasoning, but there are some rules that are put inside it. Say, for example, if the query contains something, then do this. If there is a word like this, then do it. If the query is about this, then do that. It is possible that we can give deterministic flows also. Okay, so you will say that, okay, that is workflow, but it is like a mix of workflow and LLM doing the task. Or you can give the autonomy to agent also to reason and act. So it's kind of a mix, but somewhere or the other, all agents will have some reasoning and acting capability. Okay, how much it depends on the person who is designing it. Okay, so what I'm trying to show you here, my whole summary of what I was trying to show you before we get into the project, is that graph is one way of looking at data where relationships are heavy. Relationships are, you can say, they are the first class citizens, not the facts themselves. Relationship, facts, entities, and the relationship. Don't just want to know about Ranveer Singh, but I want to know which are the movies Ranveer Singh has done and further information about those movies. So a kind of graph traversal happens. ठीक है, तो नॉर्मल रैग में डॉक्यूमेंट्स को चंक करके एम्बेडिंग कर दिया, यहाँ पे हमने डॉक्यूमेंट अनस्ट्रक्चर्ड डॉक्यूमेंट्स एंटिटी निकाला, एंटिटी से ग्राफ निकाला, ग्राफ से एम्बेडिंग निकाला, एम्बेडिंग से रेलेवेंट नोट्स निकाले, देन ऑन दोस नोट्स वी डिड ट्रैवर्सल एंड फाउंड आउट सब ग्राफ्स, दोस सब ग्राफ्स वेर गिवन एज द कॉन्टेक्स्ट. यहाँ पे एक और प्रोसेस होगा वेयर नोट्स विल बी कन्वर्टेड टू string text. Okay, I've skipped that part, but you can think that okay, nodes and subgraphs in text form will be given as the context. So high level thing is that LLM is being given context. वो context कहाँ से आ रहा है, that will depend on situation to situation. Okay, is everyone clear up till here? I have not gone into few things in detail as to first of all how these knowledge graph is created or how these embeddings are there, what type of index is there, how search happens. That's a detailed subject that has to be covered some other time. But I want you to have a high level overview of things. Okay, in 2 hours it is not possible to cover all of that. Anubhav, you want to ask something?
Sir, you mentioned about the graph-based approach and this normal vector embedding. So when to use, because both are, I mean, I think I missed that particular.
वही मैं तब से मैं वही बता रहा हूँ कि when relationships are, यहाँ पे कहीं पे लिखा था when the data is relationship heavy.
वो हमको कैसे पता लगेगा कि रिलेशनशिप हैवी है या नहीं, मतलब in a structured data. If I'm seeing first time, let's say
You will have
document.
some, you will have some idea of the nature of what you are working on, no? Say for example you are working on a data of maybe IPL data. Okay, so what type of queries are you going to expect? Who was the captain of the team who was the captain of the team who won the match in which Sachin created a century? ऐसा ऐसा अगर क्वेश्चन आ गया आपके पास, ऐसा क्वेश्चन का प्रोबेबिलिटी चांसेस है. तो इस टाइप का क्वेश्चन जहां पे मल्टी हॉप हो रहा है, जिस टाइप के क्वेश्चन में रिलेशनशिप हैवी हो रहा है, that you have to judge from on what you are working on. Okay, and whether in your system keyword search is going to be more relevant. Semantic keyword and semantic search both usually happen together. They are going to be more they will do the job, or you need hybrid approach. And in this hybrid approach you can also have like semantic plus keyword plus entities and relationship. तो ये आपको जज करना है कि आपके क्वेरी में, आपके रिस्पॉन्स के लिए क्या चीज का जरूरत है आपको. अगर आपका क्वेरीज ऐसा है जिसमें एंटिटीज और रिलेशनशिप्स का कंपोनेंट आ रहा है, then you have to go with that. And it is not that you will use this or that. You typically, what will happen, you will have a RAG that will look at multiple sources. It will look at structured data also, it will look at your RDBMS also, if the data is available there, or it can look at structured data in the embeddings, or it can look at graph also. कैसे पता चलेगा? It depends on the what domain you are working. For example, this example that I gave you of Bollywood, here you will have entities and relationships. बट इफ यू आर वर्किंग ऑन, जो एग्जांपल मैंने यहाँ पे दिया था पहले टिपिकल में, जहां पे यू जस्ट वांट टू लुक एट कंपनी पॉलिसी डॉक्यूमेंट, सो इन कंपनी पॉलिसी डॉक्यूमेंट देयर इज नॉट गोइंग टू बी अ लॉट ऑफ हॉपिंग. इट विल बी अ स्ट्रेट फॉरवर्ड क्वेश्चन. Again, I am generalizing. When whoever is building this application, they will know the best about their domain. But if I'm doing a lookup on company policy document, there I don't want to worry about too many entities, because उसमें क्या entities होगा. आप ही सोचो कि एक डॉक्यूमेंट है जिसमें कंपनी का पॉलिसी लिखा हुआ है ऑन हाउ समवन शुड ड्रेस, okay, at workplace, or what is the policy on reimbursing flight tickets, or what is the policy on holidays or maternity leave or things like that. इसमें कोई entities और relationships आएगा क्या? ये हमको सोचना है. मेरे हिसाब से उसमें कोई entities relationship नहीं आएगा, तो वहां पे ये applicable नहीं है. लेकिन अगर मैं स्टार्टअप इकोसिस्टम का डेटा देख रहा हूं, तो उसमें क्या होगा? कुछ कंपनीज होंगी, उन कंपनीज के कुछ फाउंडर्स होंगे, उन फाउंडर्स के कुछ मे बी उसका कुछ एजुकेशन होगा. And then we need to traverse it. We need to find out how many investors are from a tier 1 college, or how many people are getting investing from which firm, which firm is owned by which firm, what is the valuation of this company, that company. So all of that is not just factual, but it is also relationship. The nature of relationship is there. So that intuition we need to have about our data. But I hope from the example that I give, you are getting some clarity.
Yes, got it. मतलब आई थिंक तो एक सेफ मैकेनिज्म हो सकता है टू अडॉप्ट द हाइब्रिड, बट अगेन
typically we will always use hybrid approach.
ठीक है.
Typically we will always use the hybrid approach, and graph is RAG is not the only solution for these problems. Retrieval based problems may where I have written when retrieval based challenges may. So we some problem typical solutions here. You will see that we are having solutions like query expansion. We are having something like HYDE. We are having something called as re-ranking using cross encoders. And then one of the solution is entity extraction. Within this entity extraction, there are further problems. Okay, so I have simplified it a lot because I want to give you the high level thing. We are not going into detail of every single process, but when you are working on this in real life, all of these problems are going to come. Okay, so out of all the problems and all the solutions and all the problems in all the solutions, there is one specific thing that we are addressing. Building a graph is not the what do you say? It is not the panacea for all the problems, everything. Okay, so but it is very very helpful. And also, even if you're not working on RAG, knowledge about graph RAGs is not graph RAG. Knowledge about knowledge graphs is good. It will be helpful in a lot of other situations also. बहुत सारे retrieval में information retrieval में भी use होता है, not just in RAG but in like ranking, like Google uses knowledge graphs for ranking. So इसमें और भी बहुत सारे detailed techniques है which we will see, but today my idea was to just give you high level overview. Okay, is this clear everyone up till here? Anyone having any questions? Okay, so now we will spend, it's already 8:20, we'll spend 10 minutes to familiarize ourselves. 10 minutes with होगा नहीं, but we'll spend some time to familiarize ourselves with one graph database. ठीक है, उसके बाद हम लोग एक प्रोजेक्ट पे जाएंगे, उस प्रोजेक्ट का ओवरव्यू दूंगा एंड देन आई विल गिव यू द कोड आल्सो. यू विल बी एबल टू you should be able to clone that project and you will be able to work on it. Okay, so jaldi se let us do an introduction of a graph database and how all of this is going to happen. ये सब होगा कैसे, how this nodes will be created, is there a way to visualize these things? Okay, and how are we going to put our data inside that? So if I come back to our agenda, we have discussed about what is RAG, we have discussed about limitations of RAG, we have discussed about what is graph and knowledge graph, and now we are going to do this introduction to GraphDB. Retrieval on a knowledge graph we have discussed, so this part we are going to do, and I'm also going to show you quickly what is a Cypher query language. ठीक है, तो Cypher query language is nothing but it is just a way to write queries. So you know about SQL. Okay, you know about SQL. So SQL is a declarative language, just like SQL. It is a declarative language. What is the meaning of a declarative language? It means that you tell it what to do. You tell it what you want, and it will figure out the best way to do that, and it will give you the response. Okay, you are not telling SQL how to do things. You are just telling SQL what you want. So similarly, Cypher query language is also a declarative language that works on graph data. ओके, तो इसमें तीन चीजें होती है जब भी आप साइफर क्वेरी लिखोगे. जैसे सीक्वल में यू आर हैविंग गेट सेलेक्ट कमांड्स, update commands, set commands, delete commands. So similarly in Cypher query also you will have those things, and its syntax will be a little bit different. Please don't bother too much about the syntax. I don't have the time to go into the detail of that, and you should also not beat your head around the syntax of anything these days. Okay, we have to understand high level things. We need to understand architecture. We need to understand the system, and over a period of time, when we spend a lot of time on this, we will get the syntax also. ओके, बट जो भी काम एआई से हो सकता है वो काम हम लोग एआई से कराएंगे. सिंटैक्स एआई लिख सकता है, तो उस पर हम लोग ज्यादा नहीं घुसेंगे, बट एक हाई लेवल आपको मैं बता देता हूँ कि इसमें क्या होगा. वी आर गोइंग टू यूज on graph data. Okay, so graph data is going to have few things. I told you there are three things in graph, like we have nodes, we have entities, and we have properties. So we are going to play around with these three things. We are going to play around with these three things. So whenever we write a query, we will denote a node like this. Okay, and then we will denote another node like this, and then we will write a query here like this. So एक ऐसा हम लोग बनाएंगे. एक आप देखोगे एक डैश रहेगा और एक यहाँ पे ऐसे ऐसे रहेगा, और यहाँ पे एक कुछ रिलेशनशिप रहेगा. लाइक फॉर एग्जांपल एक्टेड इन. सो आई विल से एक्टर एंड आई विल से मूवी. ठीक है, और ये मेरा एक क्वेरी हो जाएगा. दिस विल बी वन. ऐसा नहीं होगा, थोड़ा सा अच्छे से होगा, लेकिन ये इस टाइप का मेरा एक क्वेरी हो जाएगा in Cypher query language. Okay, so you will see these kind of things, and here you can add your where condition also. So this query basically means get me all the actors who acted in a movie. तो सारे एक्टर्स को लेगा, सारे मूवीज को लेगा, और उनमें जो रिलेशनशिप एक्टेड है वो मुझे निकाल के देगा. ओके, एंड आई कैन राइट कंडीशंस हियर दैट वेयर actor is equal to Ranveer Singh, or where movie is equal to Dhurandhar, or I can say that I want to find out all the actors in a given movie or all the movies of a given actor, whatever you have done in SQL, all those type of queries we can write. So it will traverse the graph and it will give us the response. We will not have to write cipher queries in for building the project, but generally you should have an idea of whatever you are working with. You should have like a 360-degree holistic understanding. Okay, so we are going to first install Neo4j, and then we will enter some data, we'll play around a little bit, and then we will jump to our project. Okay, sounds good everyone? Yes, no, kuch bolo yaar chat mein. I will also get a little bit of motivation to talk. Okay, so here we will use Neo4j. So Neo4j is available in two ways we can use it. One is we can use the cloud instance. So cloud instance is called as Aura DB. Okay, and second is we can use self-hosted. So self-hosted we can pull from Docker Hub, and we can run it locally. Okay, the limitation of the free version is that we can have just one database. We cannot create multiple database. Or you can go for enterprise edition, which you can pay for, and then you will have facility to make multiple databases. So that is one limitation of the free version that we are going to use, but that is not of much interest, because ग्राफ डेटाबेस में आप मिक्स भी कर दोगे तो नोट्स तो अलग अलग रहेंगे, तो उससे कोई ज्यादा फर्क नहीं पड़ेगा. ठीक है, तो चलिए हम लोग जल्दी से इंस्टॉल करके उसको रन करते हैं, और उसके बाद फिर वी विल let me bring this here and I will show you how to get, we'll say Neo4j, Neo4j Docker, something like that. और एक बार Neo4j का website, let me show you. Neo4j Graph Intelligence Forum. So you can see this is the website. You can go here and it says build intelligent apps on and AI for fraud detection, and it is having a lot of things here. But we can go here and we can look at products. So you will see here that there is something called as, here you can see something called as Neo4j Aura DB. So this is fully managed service where you don't have to do anything in terms of infrastructure. And there is something called as NeoGraph database. So this is self-managed. So both options are there. And whatever code we write in the project, in that you can use either one of them. You just have to change the URL and nothing else. Okay. So if I go here, you can go here and click on start free. यहाँ पे आपको login करना पड़ेगा, and I have never tried it actually. But if you run it, business preferred, इसको मैं एक बार sign in करके देखता हूँ कि चलता है कि नहीं, कैसा चलता है. Just give me 1 second. I'm signing using my email ID. Okay, so I have clicked on sign in and it got me some username password and I have entered that. And you can see here, if I come here, I'm having some instances and इसमें मैं कुछ डाल देता हूँ, नेक्स्ट करता हूँ. ये देखो, ये एक सिंपल सा डेटाबेस मुझे बना के दे दिया कि माय नेम एंड आई एम वर्किंग एट दिस रैंडम कंपनी दैट आई एंटर्ड हियर, एंड ये सब नहीं चाहिए मुझे. बिल्ड ए ग्राफ पावर्ड एप्लीकेशन. ठीक है, ये देखो, तो जैसे जैसे ये मेरा डेटा ले रहा है एक ऐसे फन तरीके में मुझे दिखाने के लिए, इट इज शोइंग मी. सो दिस इज वन नोड and this is one node and this is one node, and it is saying that I am the person who is trying to, who works at. तो देखो ये कनेक्शन बना दिया यहाँ पे, and will use neo.j for, और यहाँ पे एक नोड है तो build something something, और यहाँ पे अब देखो फिर it is asking me which describes your role. So I will say software developer. So देखो कैसे कैसे नोड बन रहा है, generative AI. So I will say create instance. So that was just a very good UI actually, whoever is signing up. And यहाँ पे देखो it is giving me my username and password. Okay, so you can use this username and password. If you don't want to install Neo4j locally, you can do that, but I'm looking for a URI. तो एक URI देगा मुझे जब ये instance बन जाएगा. It will take maybe some time. So इसको हम लोग skip करते हैं. You can use this method, but we can use Neo4j locally also. So for locally, कहाँ है इसका docker command? एक काम करते हैं, सीधा हम लोग AI से पूछते हैं, उतना टाइम नहीं है मेरे पास. docker Neo4j docker. ठीक है. So here we can come and, क्यों नहीं आ रहा है, हाँ ये AI response आ गया. Voice is echoing. Why voice is echoing? Is the voice okay now? Application need. Is there any issue? Okay. So you can see here that it is giving me a Docker command which will directly pull the image and it will create a container for me. You don't have to do anything. It is giving you the Neo4j and password also. So you just need to install Docker in your system. Docker install कर लो, Windows और Windows या जो भी है, and Docker, you run the Docker in your system, and then just go to the terminal and you have to run this command. Nothing else you have to do. Okay, one line, everything will be working fine. So let me open my terminal. कहाँ है terminal, क्यों नहीं खुल रहा, कहाँ है मेरा? Okay, here is my terminal. So I will come here and यहाँ मैं खोलता हूँ. So I will come here, I will go to my documents. Okay, and यहाँ पे मैं बोल दूंगा docker run. Okay, and if I run this, if already it is not running, let me see if it is already running from some other project. I will go to my dashboard. Just I will run that command, and for me it ran very fast because the container is already downloaded. When you will run it, it will take some time, because if the locally that image is not present, then it has to pull from the public Docker repo. So it might take some time, but not too much time. It will just run immediately, maybe 1 minute or so. And let me open my Docker and see. तो यहाँ पे neo4j container and my neo4j, अभी कौन सा चला है मैंने, neo4j container, this is running, this is exited. Okay, so here you can see my neo4j container is running and my neo4j is up locally. Let us see वो online वाले का क्या हुआ, किधर है. Okay, you can see here that I think it is running, and I can go to my instances somewhere, कहीं पे instances here, and you will see there is one instance here which is running. So this is the Aura DB, this is the cloud instance, and I can, I think, connect to it, and then I will be able to query it also. So here you will see कहीं पे URI वगैरह क्यों नहीं दिखा रहा है, free instance running ID developer hub, you will see here all Python and everything is connected. हाँ, यहाँ पे connected to free instance, organization ID, कहीं पे URI देना चाहिए, project query. So here we can start writing query. Actually, we have not put any data match in. So here we can write some query, but saved history, cipher reference, parameters, settings, database, user, कहीं पे दिखाना चाहिए credentials. If I want to connect to it, कहीं पे होगा, अगर आप सर्च करोगे ना तो आपको मिल जाएगा. Inspect, reset to blank, recover database credentials. क्यों नहीं मिल, कहीं पे देखना आपको मिल जाएगा. जैसे यहाँ पे you are having this यूजर नेम एंड पासवर्ड, एक शायद, और अदरवाइज आई थिंक देयर इज अ कॉमन URI, neo4j or DB. Actually, I have not used it, so I don't know where it is. It is available on AWS also. ठीक है, छोड़ो उसको, अभी हम लोग लोकली चला लेते हैं, बाद में देख लेंगे. बट कहीं पे आपको उसका URI और यूजर नेम पासवर्ड मिलेगा. यूजर नेम पासवर्ड तो कहीं पे दिख गया था अपने को. ठीक है, I hope I showed you when you'll be able to see it in the recording maybe 2 minutes back. But okay, our Docker image is running. That is the interesting part, and we should be able to access it on 7474. So if I come here and if I open it, चल जा. Okay, so this is our local neo4j instance which is running, and it is running on our 7687. Here I am having database user. I should have a password. तो यहाँ पे मेरा password था, password ही था password मेरा. So it will be there in the Docker command, and if I connect to it, you can see that here I am having my neo4j. Okay, so here I should be able to now enter some data, push some data, and I will be able to query that data also. So this is our base database of graph. So I will come here, I will open my GitHub, and I have one small notebook for you which you can follow if you want to get started with this. So you can come here, and जो project है उस project में मैं थोड़ा सा practice material I have given and reading material I have given for you, so that you will be able to read and understand things. So this is the entire project. I will clone it and I will show this thing also. But if I go here, you will see something called as cipher practice. Okay, so this cipher practice will actually give you complete information about the neo4j cipher, how to run it with Docker, how to open the browser, and what to build and all. Okay, so you will see here that neo4j is a graph database. Instead of storing data in rows and tables, it is stored as nodes, relationships, and properties. तो इस टाइप से वो stored होता है data. This is how you will be able to see it. You can see here that this is one node. Node जो होगा ना, ऐसे ऐसे brackets में रहेगा. It will be like this, and relationships will be like this. It will be like an arrow and bracket. तो actually एक ऐसा होगा और एक square brackets होगा, and then there will be arrow like this. और यहाँ पे you will have acted in, or brother of, sibling of, husband, wife, whatever relationship is there, that will be stored. Okay, so you can see here it is storing like that. This database is from Bollywood data, so Bollywood वाला example से इसमें you can see that this is one node, and this is another node. Dangal is another node. Okay, and National Award is another node. So Shah Rukh Khan acted in Dangal. Dangal is a movie. So I am having one node which is person, I am having another node which is a movie, and I am having another node which is an award. So movie has won an award. Okay, Shah Rukh Khan has acted in a movie. इस टाइप का यहाँ पे relationship बन रहा है. So if I want to interact with this type of data, I need some language. So neo4j's query language is called as cipher. So you will see this type of queries. Okay, you will see match, and then this is a node. तो ऐसा लिख रहा है match, and I'm having a node. I'm saying I need a node called person, और उसका एक alias दे रहे हैं यहाँ पे which is p. Okay, and I want this person to act in a movie. तो ये arrow acted in, and यहाँ पे I'm creating another node which is movie. Okay, So this will basically get me all the persons who have acted in all the movies. Okay, and I will say return p, इस person का नाम चाहिए मुझे, so person dot name, and I want this person's age, so I will say p dot age, and I will say this movie का भी नाम चाहिए, so I will say m dot name. So if I run a query like this, then I will get a table. This table will have some columns called p dot name, p dot age and m dot name. तो यहाँ पे एक्टर का नाम होगा, एज होगा, मूवी का नाम होगा, एक्टर का नाम होगा, एज होगा, मूवी का नाम होगा, एंड दिस विल हैव द रिलेशनशिप ऑफ एक्टेड. Okay, like that we will write more queries in order to enter the data, to enter the data and query on that data. Okay, so this is find a person that has acted in relationship to a movie, return their name and the movie title. तो जितने भी लोगों ने किसी भी मूवी में एक्ट किया है, you match that and I want to return their name and title. That is what the query is. I hope after doing so much of SQL, this will seem little bit familiar to you. So this is a little bit about what is Neo4j, what is Cypher, and then it is giving you information about how to start Neo4j. I've shown you. यही command था. Maybe Neo4j version can change, but whatever username password is here that you have to use to log in. You just have to download Docker and you have to run this command. Docker should be running. Download Docker, install it, then run it, and then in your terminal use this command. So it will run the Neo4j. You have to go to localhost 7474. There your Neo4j instance will be running. They will you will need to log in. So you have to log in using this username and password. Okay. So what is the explanation of all of that? It will be given to you. Okay. So if you want to stop it, you can use this command. If you want to start it again, you can start it. So once it is done, you have to open the Neo4j browser, go to this URL in your browser, enter username, password. Okay. Then we have to enter some data. So I have prepared some data. We are not going to do LLM extraction today. That we will discuss a little bit later. We will have ready-made data that I have already prepared for you. So I told you here that the first step is that you will have unstructured documents. From these unstructured documents, you are going to have entities and relationships. So many entity relationship I have prepared already and I have kept it. So this process we are not doing. Although in the code you will find this thing also, but I have not clarified that properly. I will clarify that and I will make a push. So after 2-3 days, if you see, you will find that also. But today I will just show you this part. I will have ready-made data, and that ready-made data we will put in the knowledge graphs, and then we will do the entire process. Okay? Everyone with me so far? Please tell me. Okay. So our database is going to have this kind of relationship. We are going to have some nodes called person. So person can be actor, or it can be a director, or it can be a composer. So if you think in terms of Python classes, I will have person, actor, director, composer. उसको inherit करेगा, उससे हम लोग schemas बनाएंगे, वो schema LLM को देंगे और LLM को बोलेंगे कि मेरे unstructured data से सारे persons को निकालो. जो भी persons निकलेंगे, उस persons में कुछ actors होंगे, कुछ director होंगे, कुछ composer होंगे. Now these are the main nodes, and then I will have movies. So what are the entities? Actor is an entity, director is an entity, and composer is an entity, and movie is an entity. ठीक है, और क्या है, awards भी है शायद. Okay, maybe directors are also there, whatever. So actor will be acting in a movie will be directed by somebody, movie will have a composer, awards, composer will win awards, actor will win awards, director will also win awards, movie will also win awards. तो इस टाइप का इसमें बहुत सारा ग्राफ बनेगा. So this is our schema. Okay, so we are going to load the data. So these are some constraints in SQL. You know, there are some constraints like name cannot be unique, movie title cannot be unique. So here these are just putting some constraints that whenever I am entering the data, I don't want two nodes where the name is same. Basically, if Shah Rukh Khan is a node, I don't want another node for Shah Rukh Khan to be created. So I don't want duplicate nodes. I don't want duplicate movies. I don't want duplicate awards. So this is basically I'm creating some constraints here. Okay. So I'll just copy paste this and I will go to my Neo4j and I will paste it here and I will run my query, and the query has run. So now I will go back and I will कहाँ गया, कहाँ काम कर रहे थे हम लोग, यहाँ पे. Okay. So I will create some nodes. So I will just going to create one node here. Okay, I'll show you this node I'm going to create, and you will see what this node is saying. Okay, zoom होगा क्या? See, I'm going to create one node here. This node is going to be of the type person. ठीक है, तो this is of the type person. ठीक है, and inside that I'm going to have some properties. So properties में I will have name, and name will be Shah Rukh Khan. SRK मैं short में लिख रहा हूँ. Okay, and then for that I'm going to set. You know, in SQL you are having something called as update set. So here also I'm having bond. So there will be bond, and bond will be 1965. I will have profession. It will be actor. I will have hometown. This will be Delhi. Okay. So this you can also think of in terms of a Pydantic class. Okay, it is important to relate it. So I will have something called as actor. The actor will inherit from person, maybe, and here I will have maybe name. Name will be string, and I will have this will inherit from base model. Sorry. तो जब हम एक्सट्रैक्ट करेंगे तो हम इस टाइप का स्कीमा लिख के एलएलएम को देंगे कि मुझे ऐसा निकाल के दो, तो सारे एक्टर्स के पास नेम होगा, सारे एक्टर के पास बॉन्ड होगा, सारे एक्टर्स के पास एक प्रोफेशन होगा, एंड सारे एक्टर्स के पास एक होम टाउन होगा. So if I know this schema, then only later on I can convert it to a sentence also. So I can say SRK, who was born in 1965, who is an actor, Delhi-based actor who acts in Hindi movies, things like that. I can create a sentence, and that sentence will be created into embeddings. और यहीं पे कहीं पे हम लोग embeddings भी store कर दें. Embeddings भी store हो जाएगा यहीं पे. Okay. और इस embedding के basis पे इस node को we will be searching during the query time. I hope that part is clear. Okay. So I'm going to run this query. I'm using the command merge here. Merge basically is like if duplicate is existing, then it will not do anything. If it is not already there, after embedding, data remains. Matlab, data will be there. Data will also be there. Embedding will also be there, and the sentence will also be there. I will show you everything. Okay. So I'm using this merge. So this merge is nothing but in SQL you will have something called as create a table if not exist. Create table if not exist. Okay, so that you don't create duplicate tables. So this merge is for that only. Again, don't worry too much about the syntax. So I'm going to run this command now, and we will see that this command has run. And now I want to see my database. कि database में मेरे क्या क्या है. So I can run the query. I can say match all the nodes, and I will say return all the nodes. Return all the nodes. Okay. So if I will run this query, you will see I'm having one node which is called Shah Rukh Khan here. Okay, now I want to add some more actors also. So I will go here, and you will see I have so many actors here. Amir Khan, Salman Khan, Hrithik Roshan, all of them are having same data. So I'm going to copy them, and then I'm going to have some music composers also. So I'm going to come here, and I'm going to put all of that into my database, and I'm going to run it. Okay, so after that, if I run my query match, and तो अभी तक मैंने कोई भी relationship नहीं बनाया. I have just created nodes. So I will just see nodes which are disconnected with each other. Lot of nodes. So you can see here I'm having a lot of nodes. If I look at this node, this is for Rajkumar Hirani, and if I click on this node, it is about Anurag Kashyap. Anurag Kashyap is a director. His hometown is in UP. He was born in 1972. And if I click on this node is about Zoya Akhtar. This node is about Farhan Akhtar, and this node is about Shah Rukh Khan. Okay, so now we are going to create some more entities. So I will create some movies also. तो यहाँ पे कुछ movies भी बनेंगे. Okay, and when movies are created, then we will also have connection between the movies and actors. So if this is Farhan Akhtar and this is Zoya Akhtar, then there will be a relationship called brother sister. If there is Javed Akhtar, then this will be a connection called father. Okay, so if I want to have any information about which is the most successful movie created by son of Javed Akhtar, so Javed Akhtar पे हम लोग आएंगे embedding search से, और जावेद अख्तर से हम लोग फरहान अख्तर पे पहुंचेंगे नोड हॉपिंग से, और फरहान अख्तर का मूवीज यहाँ पे कुछ होगा, मूवी नंबर 1, मूवी नंबर 2. तो ये सारे मूवीज को हम लोग रिट्रीव करके एलएलएम को दे देंगे in order to respond to the answer or question. So this is the whole summary of what we are trying to do. Okay, is everyone clear, guys? कितना टाइम हो गया? 8:46 हो गया. Okay, so कुछ movies में I'm going to create some movies here. So you can see what is this movie. Again, I'm creating a node of type movie, and inside that I'm setting year of the movie, genre of the movie, box office, collection, description of the movie. Okay, so you can see the description here. I'm having love story of Maratha warrior and story of Mahavir Singh Phogat. So if you are having a query that who was the director of the movie about Mahavir Singh Phogat, so Mahavir Singh Phogat will bring you to this node, vector search se. And after that, for this movie you want to find the director, so that you will go through relationship edges. ठीक है, I hope you are able to understand that. So I have run that query, and यहाँ पे जाते हैं. मूवी नोट्स हमने बना दिया, और क्या बनाना है? ठीक है, ये सारा डेटा structured तरीके से I have prepared, but actually this is structured you will not have. You will have to create it using unstructured data. So that discussion we will have it separately. Okay, so these are production houses. Okay, so I'm going to create production houses, and then I'm going to create awards. So I'm still creating all the nodes. I have not created relationships. So now I think we will have some relationships. So you see now there are relationships. So you will see here that I'm having एक relationship में बनाता हूँ यहाँ पे पहले आपको दिखाने के लिए. See, वो query दिखाना था एक बार. हाँ, you see what is the query here. Let me zoom it. Okay, see what is the query. I want to create a node which will be Shah Rukh Khan, and I'm having one node which is DDLJ. Okay, these two nodes are already created in the previous queries. Now you will see that I'm doing a match person Shah Rukh Khan, so it will return this. ठीक है, इसका नाम हमने रख दिया P, यहाँ पे P. ठीक है. एंड देन आई एम हैविंग अ मूवी टाइटल दिलवाने दुल्हनिया ले जाएंगे, इसका एलियस दे दिया मैंने एम, यहाँ पे बोला मैंने एम. फिर यहाँ पे क्या बोल रहा है कि मर्ज पी एक्टेड इन लीड रोल एम. सो आई एम सेइंग दैट पी एंड एम, इसके बीच में एक रिलेशनशिप बनाओ विच इज एक्टेड इन. ओके, नोड को ऐसे दिखाते हैं, ऐसे ब्रैकेट यू कैन सी हियर, और जूम कर दे, यू कैन सी हियर दिस नोड merge and then bracket p acted in, and then that node is also having some property. Okay, so this also we will discuss later, that this is one node and this is another node and there is acted in, and is relationship maybe there is some property. For example, Shahrukh Khan ka character name kya tha, so that was Raj Malhotra, and whether it was a lead role, so lead role is equal to true. Okay, so if you want to find out uh, which are the movies of Shahrukh Khan in which he has played a lead role, so this is Shahrukh Khan, he will be connected to a lot of other movies. So when the question contains a Shahrukh Khan, vector search will bring you to Shahrukh Khan node, and then node hopping will take you to all his neighboring movie nodes, and in those movie nodes some of them lead role will be true, some of them lead role will be false. So if the user is asking only about the lead role, then we will be able to get that information. Okay, are you able to follow that why what exact problem graph is solving? That is the main takeaway I want you to have in today's discussion, that relationships are being captured. इतना भी अगर आपको याद रहेगा इस पूरे सेशन के बाद, तो आई विल फील दैट 2 hours of this workshop
Sir,
was fruitful.
sir,
हाँ,
the query is case sensitive or it can have some typo or something like that also.
that all of that is not a problem. That LLM will take care. LLM को आप कुछ गलत स्पेलिंग दोगे तो वो क्या नहीं समझेगा. केस
नहीं,
सेंसिटिव से LLM
कोई
केस
मान
केस
लीजिए
सेंसिटिव.
सर कोई क्लोज वर्ड्स हों तो उसमें तो इट कैन कंफ्यूज.
वो सब डेटा प्रिपरेशन पाइपलाइन का एक तो पार्ट होता है. दूसरा, एक एलएलएम को अगर आप एप्पल बोलो और आप एप्पल बोलो, तो उसको एलएलएम क्या इसको रीजन नहीं कर सकता है कि एप्पल की ही बात हो रही. कोई कोई रूल बेस्ड सिस्टम थोड़ी ना है. एलएलएम अपने आप में एक इंटेलिजेंट बीइंग है ना. या फिर जब हम इसको चंकिंग करते हैं, तो चंकिंग वाले पाइपलाइन में बेसिक डेटा प्री प्रोसेसिंग में ये सारी चीजें हम लोग हैंडल कर लेते हैं.
राइट.
हाँ, अगर बहुत ही ज्यादा गलत स्पेलिंग लिखोगे तो फिर उसका एम्बेडिंग ही गड़बड़ हो जाएगा, तो फिर वो सर्च आएगा ही नहीं ना. ओके, so this is me creating a relationship now. Oh, I hope you understood the syntax of that. So I will go here and ये query चल गया है, and let me come back. And now if I do my query match and return in, somewhere that relationship should be shown. क्यों नहीं show हो रहा है, क्या हो गया? Now we are able to see the relationships. Nodes only showing the nodes. It is only showing the relationships. Let us add. Okay, you are able to see the relationships, right? You can see here Shahrukh Khan, and Shahrukh Khan has acted in a lot of movies. Chennai Express, My Name is Khan. And if you go to any particular node, say for example, I'm clicking on this acted in, you will see that My Name is Khan, the character was Rizwan Khan, lead role is equal to true. If I come here, you'll see Shahrukh Khan and movie Jawan, and the character name is Vikram Rathore, and lead role is equal to true. So of course, Shahrukh Khan, whichever movie he will be doing lead role only. So if I come here to Bajirao Mastani, now this is a movie. So movie is connected to other actors. So for example, Deepika Padukone acted in a movie. Okay, so this movie can also have directors, producers. So all of that data I have not entered. वो सभी data मैं डाल देता हूँ इसमें. So ये directed का relationships है, इसमें मैं डाल देता हूँ. And then I'm having some composed relationships. So this is movie composed. ये भी मैंने डाल दिया. और क्या है इसमें? Produced और awards. तो ये बहुत क्लीन डेटा मैंने इंटेंशनली बना दिया आपको दिखाने के लिए, ताकि मुझे प्रॉब्लम ना हो, लेकिन रियल लाइफ में आपको ऐसा डेटा नहीं मिलने वाला है. ठीक है. सो हियर आई हैव क्रिएटेड एवरीथिंग, एंड नाउ इफ आई गो एंड लुक एट, इफ आई डू अ मैच एन एंड आई डू अ रिटर्न एन, रन दिस क्वेरी, दिस इज बेसिकली सेलेक्ट स्टार. ठीक है. और यहाँ पे मैं जाऊँ तो यू विल सी इतना कम क्यों आ रहा है, फैक्टेड इनका रिलेशनशिप्स क्यों आ रहा है. अच्छा, यहाँ पे लिमिट लगा हुआ है इसीलिए इस पर, सॉरी. 25. हाँ, अब देखो ये पूरा नॉलेज ग्राफ हमारा बन गया. यू कैन सी. Okay, only from a small data set, you can see this is a graph. Here you can see that I'm having Ranveer Singh, he got one award also, and Ranveer Singh acted in Gully Boy also, and Gully Boy was composed by Amit Trivedi, Best Filmfare Award it has won, and you can see that it was produced by Excel Entertainment. Excel Entertainment has also produced Zindagi Na Milegi Dobara. Zindagi Na Milegi Dobara was directed by Farhan Akhtar. Farhan Akhtar has also directed Dil Chahta Hai. So now you can see that we will be able to answer questions like which is the other movie by the director of Dil Chahta Hai. So Dil Chahta Hai has come. So you will land here, vector search. Okay, and from vector search you will go to Farhan Akhtar, and this Farhan Akhtar will have other movies which is Zindagi Na Milegi Dobara. So between Dil Chahta and Zindagi Na Milegi Dobara, we are able to establish a relationship through Farhan Akhtar. Okay, that's the whole point of doing this. Okay, so this is the data that we have created using Cypher query. So this is a little bit about Neo4j. That's all I wanted to show you. So I can come back here and I can say that we have discussed about introduction to GraphDB and Neo4j Cypher query language. Okay, okay, guys, it's already 9 o'clock. Can I take 10 minutes more?
Sir,
Yes.
one question.
हाँ,
सर मतलब जैसे आप बता रहे हो Neo4j इट्स अ रिलेशनशिप हैवी दिस डेटाबेस, तो मतलब कैन टू सम एक्सटेंट इट कैन बी रिप्लेसमेंट ऑफ RDBMS थिंग आल्सो?
RDBMS और ग्राफ डेटाबेस का काम अलग अलग है.
नहीं मतलब अंडर द हुड तो उसमें भी रिलेशनशिप्स ही बन रहे हैं.
किसमें? आपको अगर
RDBMS.
एक RDBMS में रिलेशनशिप बनाना है,
हम्म.
मल्टी हॉप रिलेशनशिप बनाना है, तो आपको वहां पे जॉइंस करना पड़ता है. वहां पे भी रिलेशनशिप है, लेकिन वहां पे आपको जॉइंस बनाना पड़ेगा. वहां पे नोड ट्रेवर्सल नहीं होगा. अगर आपको ये मालूम करना है कि रणवीर सिंह की वाइफ कौन है और रणवीर सिंह की वाइफ ने कौन सा दूसरा मूवी किया है, तो आप पहले दोनों टेबल को ज्वाइन करो, फिर उसको मूवी टेबल से ज्वाइन करो, उसको फिर आप डायरेक्टर से ज्वाइन करो, फिर उस डायरेक्टर का दूसरा मूवी निकालो. सो यू विल हैव टू राइट अ लॉन्ग SQL queries with lot of joins.
हाँ, that is what I'm saying, sir. कि Neo4j is a better thing towards that thing.
No, for
No?
this purpose, not general purpose. RDBMS अपनी जगह पे है और GraphDB अपनी जगह पे है.
Okay.
ओके, हाँ, इसमें भी इंडेक्सिंग होती है इसका परफॉर्मेंस इंप्रूव करने के लिए, इसमें भी इंडेक्सिंग होती है इसका परफॉर्मेंस इंप्रूव करने के लिए. इसमें जिस तरह की इंडेक्सिंग होती है वैसी इंडेक्सिंग यहाँ नहीं होती है. यहाँ पे यू हैव समथिंग कॉल्ड एज HNSW, नेविगेबल स्मॉल वर्ल्ड टाइप की टेक्निक्स होती हैं. तो और यहाँ पे आप बी ट्री वगैरह यूज करते हो. Okay, so these are two very different things, and depending on the use case we are going to use them. So if you have structured data already, then you use RDBMS, but if you want to explore relationships only, then you use GraphDB. What is the next step? What we have to do, guys? I need 10 more minutes. I tried to finish it before 9. मैं तब से घड़ी देख रहा हूँ, लेकिन this is Docker based only. Yes, you can install it otherwise also, but why you want to take that headache? आई थिंक उसके लिए फिर npm और जावा बेस बहुत सारा कुछ इंस्टॉल करना पड़ता है. सो डॉकर इज द इजीएस्ट वे. नो, यू हैव जस्ट वन लाइन यू हैव टू रन एंड इट विल, इट्स द बेस्ट वे. अदरवाइज आल्सो इट माइट बी, बट आई हैव नॉट tried to install it. Neo4j local instance install. I think there is a Neo4j desktop app also. Let me see. Desktop app, desktop download है, तो यहाँ पे आप ट्राई कर सकते हो. This also you can try. Where it stores the DB. DB is locally. आपके it will be, if it is local hosted, it will be in your system, but it will be inside that Docker. So when you kill that Docker, your database will be gone. So for that, there is another techniques, like you can mount your local storage inside Docker. So whatever is happening inside Docker, persistent storage will be in your hard disk, so that when you eliminate the container, when you kill the container also, your data will be persisted. So when you create a new container from the image, then it will take the mount the same hard disk and same storage, and it will data will be persistent. So all those things you can do, but I'm not covering all of that. I hope I am
Okay.
answering your question.
Yep,
Pradeep.
got it.
ठीक है. डॉकर देखो हम लोग इसलिए यूज करते हैं ना, क्योंकि बहुत आसान होता है. अब प्रोजेक्ट भी
Environment
हमने
ready.
बनाया है. हाँ,
Environment ready.
एनवायरमेंट रेडी रहता है. आपको यू डोंट हैव टू बैटल ये डिपेंडेंसी वो डिपेंडेंसी. मैक में चल रहा है, ubuntu में नहीं चल रहा है, ubuntu में चल रहा है, इसमें नहीं चल रहा है, तो विंडोज में नहीं चल रहा. ऑल दैट हेडेक इज नॉट देयर. ओके, सो कहाँ थे हम लोग? So you can download this also. You can try it out. Honestly, I have not tried it out. So it is already giving you option of start free with AuraDB. So you can use AuraDB also. यहाँ पे हमको AuraDB का भी एक इंस्टेंस बना के दिया गया है. तो यहाँ पे भी जाके हम लोग ओके, यहाँ पे ऑप्शन आ रहा है पर्सनल, प्रोफेशनल, फ्री ट्रायल, प्री डिफाइंड RBAC बैकअप्स, ब्ला ब्ला ब्ला, 0.09 GB per hour, क्लाउड प्रोवाइडर, फ्री मैक्सिमम फ्री इंस्टेंस. अच्छा, एक ही इंस्टेंस बना सकते हैं. वो एक इंस्टेंस मैंने बना दिया. इसका URI कहीं नहीं. इसमें यहाँ पे जाके अगर ओपन करे, ओके, क्वेरी करे, तो हियर ऑल्सो यू कैन गो एंड राइट योर क्वेरीज. हियर ऑल्सो आई कैन कम एंड वट एवर क्वेरी आई हैव रिटन, these queries I can run it here also. This is my AuraDB. So this is remote instance. This is managed instance. So it will be in the server of wherever you are running. So you can see here also I can run the query, and I can come here and I can then match and return, and I can run the query, and you can see all my nodes are here. But this is running on the cloud instance. Okay, you can use both of them. either ways, cloud instance will be much easier. Local instances for convenience. So let me go to our project. This is our project, and you can clone it. It is public now, and you will have one README file here. In this README file, all the details will be explained. So what exactly is this project? This project is a very simple project where we have some data about Bollywood, and we want to store that in a knowledge database, and then we want to query that DB. Okay, query, our user will ask some questions, and we will be querying the information in the knowledge graph, and we will be returning that answer. Okay, so what are the things that are there? What in this project, what are the things that we are covering? First of all, graph database fundamentals we have covered already. So Neo4j with a Bollywood ontology. Ontology is nothing but क्या क्या चीजें एग्जिस्ट करती हैं, एंटिटीज, रिलेशनशिप्स, directors, producers, so पूरे landscape में what are the entities. Then cipher query language we have already discussed. Vector embeddings on graph nodes. This is very simple. If you know already, you will have a node, you will convert that to sentence, and that sentence you will pass to OpenAI embedding, and it will create embedding. That embedding will be stored in the node itself in this project, but you can store it in some database also. Okay. Then graph RAG pipeline. So you will do vector search. After that, you will do graph traversal. After that, you will do LLM answer. This is only we discussed. We will do vector search. This vector search will give us the nodes. From this nodes, we will do subgraph, or I will say neighboring nodes. And nodes plus neighboring nodes, in दोनों को मिला के we will pass it to the LLM. And LLM will give us the answer. Okay, so that is there. And then all of this will be exposed using a fast API backend. So we will create a fast API backend. In that backend, we will have some endpoints like ask a question, or search for an actor, or search for an actor, search for a movie, or details of a movie, something like that. So you can have different endpoints, and once you have these endpoints, then you can create a UI front end out of it. So you can use, if you know, if you are good with UI, or if you have a friend who is a front end developer, you can ask him to create a nice website using JavaScript and CSS and everything. But I don't know anything about that, so I am using poor man's UI, which is Streamlit. So Streamlit is a framework in Python that will allow you to create simple UIs, and we are using Docker here. So there are going to be 3 services in this project. Let me show you that there will be 3 services which will be talking to each other. So the first service will be our, of course, let me call it Bollywood graph RAG. So we will have first our Neo4j, then we will have our fast API. ठीक है, so Neo4j 7474 port पे run होगा. Fast API will be running on maybe 8000 port, and then we will have our Streamlit, which will be UI. Now this Streamlit can be replaced by any other UI service if you have based on some JavaScript, if you have created whatever. Okay, you can put your UI, and this UI will be talking to this backend, and this backend will be using our graph database functions to answer the question. Okay, so this will be running on Streamlit, will be running on where Docker Compose में लिखा होगा कहीं 8000, and Streamlit will be working on 8501. So 3 services will be there. If you want, you can run them separately also, or you can define all these services inside a Docker Compose. That's what I have done. I have created one Docker file for Neo4j, one Docker file for Fast API, one Docker file for Streamlit. Okay, so there will be a Docker file for this, there will be a Docker file for this, and there will be a Docker file for this. And then all these 3 Docker files we can orchestrate using Docker Compose. So what you have to do, you have to just run one command, which will be Docker Compose up or Docker Compose build, and all the services will be up, entire project will be live, and you will be able to run it locally. Then if you want, you can also deploy it on some AWS instance, and then all these 3 things will be working for you. If you want to change Neo4j to maybe some other cloud instance, then you just have to change one URL, and instead of your local, it will be working there. Fast API you can deploy as a separate service also. Here it is in the same service, same Docker Compose, but Fast API can be on some other instance which is running. So then you get a microservice kind of architecture. Okay, you can expose it as a Lambda. You can expose it as a Lambda function also, or you can use, I think, ECS, Elastic Container Service. There you can put the Docker, and you can expose those endpoints using API gateway, and you will have your Streamlit application running in a separate port. So this way, these are the 3 services. You can run them together. You can run them as separate also, whichever way you want to orchestrate it, you can do that. Okay, so let me go here, and I will clone this project, and I will quickly show you if I have it already somewhere. Just give me one moment. I think I've already cloned it. Okay, so here is everything. So I will quickly give you a walkthrough of what are the things that are happening here, high level. I'm not going to go and explain each and every line of code. We can do that later if you want, but I hope you guys are know Python well enough to understand the functions. But I will tell you what are the main highlights. Okay, already I've told you the main highlights. Fast API will be there. That will be the entry point. Sorry, UI will be there. That will be the entry point. UI will call the fast API. Fast API endpoint is going to run the entire retrieval pipeline. In the retrieval pipeline query रहेगा, query का embeddings होगा, उससे हम लोग node के embeddings को search करेंगे, we will get the correct nodes and then we will get the subgraphs and then we'll convert everything to string and we'll pass it to context and query will go to the LLM will generate the answer, fast API will give the answer to the UI will show the answer to the user. That's the whole pipeline. Okay, so you can read about things here, but I will give you a small walkthrough. So if you go to this SRC here, in SRC, first of all, you will find this data folder. Data folder inside, you will find this Bollywood data. So this is the hard-coded data. This is the data that actually we have to extract from unstructured data, maybe some Wikipedia pages, etc. But we have not done that. I have not done that. But I have ready-made dictionaries here. This I have generated using AI. I just asked AI to generate 100 actors, 100 30 movies and 30 awards, something like that in a given format. Okay, I gave it some a structure and based on that structure it has given me, but actually LLM has to look at the unstructured data and from there it has to extract. Okay, so that part is a disclaimer. I have already prepared this so that data is clean, so that you don't have to bother about unclean data, because that's not the focus of what I'm trying to show. Okay, so I'm having some actors here and then I'm having some directors here and then I'm having some production houses, movies, etc. Whatever I showed you in the GitHub, same thing is there in Python dictionary format. Okay, so the first thing that we have to do is we will run our loader. So first we will create our Neo4j connection here. So I'm writing one Neo4j connection here. We will import from Python. We'll import Neo4j library, and inside that Neo4j library we will create our connector, just like how we created SQLite connector or Postgres connection we will create in our fast API course, something similar to that. So here we will pass the URI. So here URI is running from locally. Actually this should be in a config file. यहाँ पे मैंने कोड के अंदर यूजर नेम पासवर्ड डाल दिया. दैट इज अ वेरी बैड हैबिट. ओके, सो यू शुड नॉट डू इट लाइक दिस. एक्चुअली इट शुड, okay, sorry, it is coming from environment variable, so actually it will come from environment variable. So we will have this URI username and password and it will give me a driver. Based on this driver I'm going to write a query. So I'm having a function here that will take the driver, it will create a session, and inside the session I will run the query. Okay, just like how we do it in SQLite in Python. Okay, you create the connection to the database and then you write the query and it is generating it. The only thing here is that I am writing queries and parameters separately. This is a very, very important interview question that you can get here, that why when we are writing queries, why we are having this query and parameters separate. Okay, why not use something like a f string to concatenate and create the query? So if you are not understanding the question, no problem, but if you are able to understand the question, then try to find the answer for this. It's a very interesting answer. It is related to security and SQL injections that can lead to some security issues. Okay, user can give some fault, user can give some uh, uh, mischievous queries that can get appended to your query and it will run. So that is not how we should run it. We should always have query and then we should have placeholders, and user should only give the information for the placeholders. User should not generate any query, or user input should not be appended to the query. Okay, so here I'm having a write command and here I'm having a read command, and basically it will just have a query. And what are the queries? Queries will be whatever we have seen: merge, movie, title, relationship, whatever. So this is example query, and this is basically our connector. So whenever we have a query, we'll use this connector and we will execute the query. It will go into our database. So the first thing is that we will run our loader. So loader will basically take the data from Bollywood data and it will use the connector for the DB and it will push the data. So you saw that when I was giving you the demo, first thing I did was I put the constraints. Okay, so here I'm loading the constraints, then I'm loading all the people. First thing I did was second thing I did was I added all the actors, movies, etc. Okay, so I'm going to load all the people, then I will load all the movies, then I will load all the production houses. Why I am doing them separately is because the schema of all of them are different. So in one function I cannot do all of that. Okay, so that's why I'm doing it separately, and I'm loading all the awards, then I'm loading all the relationships. So you see nothing, it is just the same query, but instead of doing it directly, we are doing it using Python. If you can do it directly, then this function is also not needed. जैसे कि अभी मैं इसको रन करने की जरूरत नहीं है, because my database is already having this data. ठीक है, but if it is not having, if you are running it separately, then you can run this command. And in what order you have to run what, everything is documented in the README. You can go through that. Okay, so here basically same thing is happening. If you see what I showed you, I am getting a person, and then I'm getting a movie, and then I'm doing P acted in movie. Okay, so that is we are doing here. Okay, and in that we are doing this relationship. You can see this P acted in movie, and I'm having a relationship is denoted by R. Okay, and then I'm doing R dot character name. तो R dot character name यहाँ पे character आ रहा है, R dot lead role lead आ रहा है. See, this part is coming from the user, whatever is in dollar. ठीक है, और उसको मैं as a parameter pass कर रहा हूँ. Okay, so you will see that how this functions are running with query and parameters. We are not appending anything. And then we are having directors, and then we are having composers, producers. I hope you get the gist. Okay, so once all of that is done, then I'm loading everything together so that all the data is pushed into our system. So right now, once this much is done, all the data is there in our system. ये काम हमने already कर लिया, so that is not much of interest. Okay, after that, what we have to do, we have to create embeddings. Okay, we have to create embeddings. So I will write here step by step what we are doing. Guys, it's already 9:16. I hope you guys don't mind extending a little bit. Okay, the first thing is create connection. The second thing is load data, which is nodes and entities and nodes and relationships. Then third step is create embeddings. So here I'm creating embeddings only for the nodes, but you can create embeddings for the nodes and relationships also. So there is some way of doing that, but in this project I have not done. I'm creating embeddings of only nodes. Okay, so this much is our preparation part. Okay, once the preparation is done, then we will have the query, and this query will be compared to these embeddings, and this will give us the nodes, relevant nodes. Once we get the relevant nodes, we will traverse and we will get subgraphs. And once we get the subgraphs, this we will give to the content. ठीक है, तो इसका फ्लो कोड में कैसे हो रहा है वो मैं दिखा देता हूँ आपको. ओके, सो हियर वी आर हैविंग एम्बेडिंग्स. सो एम्बेडिंग्स के लिए क्या कर रहे हैं, मैंने बोला था कि whatever for to create embeddings, what we will do is whatever node we have, this node information will be converted to a sentence, and this sentence will be given to our embedding model, and this embedding model will give us the embeddings. Okay, so here you will see that is what is happening. Because the structure is already known, I'm using OpenAI here, and I'm doing the embedding using this OpenAI model. You can use any model, whichever model you want. And I am doing node to text. So for every node, I'm creating a sentence. So for example, if it is a movie, so I will do movie, say for example, Dhurandhar is a action movie, Hindi film, okay, and released in some year. So I'm creating a sentence, and in that sentence, I'm using f-string to get the properties. I know the properties, therefore I know every movie will have same description. Okay, template will be same. Here, person I'm creating, say for example, Shah Rukh Khan is an Indian actor or director or movie. Okay, born in so and so, and from Delhi or Mumbai or whatever. Okay, so similarly, I will create sentence for all of them, and then I will call the OpenAI model. I will pass all the text, and I will get all the response. Okay, so that embedding I will create as a list. Okay, once I have the embeddings, then what I will do, I will put the embeddings in the node. जिस नोड का हमने एम्बेडिंग बनाया उसमें हम लोग डाल देंगे. सो whatever node I'm having here, in this node I will add two more things. One will be this sentence. इस sentence को भी यहाँ पे स्टोर कर लेंगे, so that in context we will be able to take that sentence out, and this embedding also I will store here. Okay, so I will, if this is n, then I will do set n dot sentence is equal to whatever the sentence is, and I will do set n dot embeddings whatever this embedding is. So these two commands I will run here. You will see that here you will see embed every node in the graph and store the vector as a JSON string property. So here, if you come here, you will see I'm doing n dot embedding is equal to the vector, and n dot embedding text. This is basically n dot sentence, and I'm setting it to text. After doing this, I'm pushing all of that to my database. So now my database has all of this information. Okay, so इतना मैं अगर रन करके दिखाऊं आपको एक बार मैं Python. I'm just running the embeddings pipe because loading I have already done and I've shown you. Actually, it may not work because इसका वाला अलग से चल रहा है. Client error, client is another authentication failure. This is using a separate Docker. So let me close mine. जो आपको मैंने दिखाया वो वाला Docker इसमें नहीं है, उसका यूजर नेम पासवर्ड अलग है. So इसको किल करना पड़ेगा. Let me stop this one. It will take some time to stop. and I will run iska wala Docker. So let me look for Docker compose up. I'm only running using Docker to run the Neo4j. I'm not using it to run other things. Command. So I'm taking my Docker command. Inside that Docker command, Docker compose, I'm having 3 services, but out of those services, I'm only running Neo4j. Dash D means detached. Okay. So if I go here now, I should have my Docker running, the new one. Okay. You will see slight version change, UI will change. दोनों का वर्जन अलग अलग है कहाँ है ये वाला इफ आई रन इट यू विल सी हियर नाउ दिस हैज चेंज्ड सो इसका पासवर्ड अलग है लेट मी सी व्हाट इज द पासवर्ड ऑफ दिस वन डॉकर कंपोज में जाके आई एम हैविंग पासवर्ड बॉलीवुड 24 लेट मी रन दिस अच्छा तो जो मैंने पहले डेटा लोड किया था वो दूसरे में था तो दैट विल नॉट गेट काउंटेड नाउ सो आई विल हैव टू रन द कमांड अगेन सो लेट मी पुट दिस हियर एंड आई विल रन माय गो टू माय src and I will run cd src में ही है so I will run my python loader.py so this is going to load all my data so it is loading all the data now basically running the same queries which I ran earlier but that was a different database then I will run my embeddings okay so python embeddings I hope my key is there so it is creating my embeddings actually okay so you can see here that all the embeddings added so what you have to do you are having one .env.example file here okay तो यहाँ पे this is giving you the template of how you have to store your environment file so what you have to do you have to copy this file and you have to create a .env.example है you have to copy that and you have to create this file .environment file and in this .environment file you have to put your actual username and password here for demonstration I am using the new this username and password but you have to put your own username password and you have to use your own OpenAI key okay so in my environment file I am having a .env file which is a copy of this file लेकिन उस file में मेरा ये सारा data stored hai so I'm not going to show that because that is having proprietary my API key so but I hope you understand so this is a common pattern that you will see whenever you are having .env files you will create a .env.example so that the person who clones the repository he knows what are the information to be present in the env he will just replace the he will do fill in the blanks and his project will be running okay so now my embeddings is done so if I go to my database here yahan pe and if I come here and if I do match n I will show you match n and I will say return n यहाँ पे you will see that here if I go to any node किसी भी node में जाएंगे तो you see what are the information available earlier I was only having the category and I was having the name and the year for the movie but now you see I'm having embedding also this embedding I have created and I've stored here only and I'm having embedding text also so you see this embedding text is generated based on the other feature so it says the Filmfare Best Actress Deepika 2016 is the Filmfare Award presented in 2016 Indian cinema. Okay, so this is the name of the award. I don't know what weird award this is, but it is the name of the award. I can go to some other person maybe. कहाँ गया? You can see here. This is a movie. Okay, so this is the description of the movie. This was given in the data. But this is the embedding text. This is generated based on all the data. So you see, it is crime drama Hindi Gangs of Wasseypur. So you can read here that Gangs of Wasseypur is a crime drama Hindi film. Crime drama Hindi film released in 2012. 2012 कहाँ से आ रहा है? कहीं पे होगा 2012. हाँ यहाँ पे 2012. Okay, released in 2012. A multi-generational saga of coal mine mafia. वो यहाँ से आ रहा है मल्टी जनरेशन सागा ऑफ कोल माफिया तो जो भी इंफॉर्मेशन था उस इंफॉर्मेशन को हमने एक सेंटेंस में कन्वर्ट कर दिया इस एम्बेडिंग टेक्स्ट का हमने एम्बेडिंग बनाया और वो एम्बेडिंग यहाँ पे स्टोर्ड है दिस एम्बेडिंग विल बी यूज्ड फॉर वेक्टर सर्च ओके आई होप ऑल ऑफ यू आर एबल टू अंडरस्टैंड हाउ थिंग्स आर स्टोर्ड वेयर व्हाट इज स्टोर्ड okay so now if I come back guys please say yes or no in the chat or are you guys all sleeping okay so now we have created our we have created our embeddings now let me go back to our api.py so this is our fast API endpoints so if you come here I'm having some endpoints here like ask search graph stats health and cipher okay so cipher will allow you to run any query which user is giving simply I have added here don't use it main thing here is ask okay so here you will ask a question and graph rag will be answering that question okay you can also do search you can also do graph/name these are all query URL parameters which will allow you to get relationships of a given person okay but you can try them out but major thing here is ask so if I go to ask here ask endpoint here basically I'm using our fast API and Patentic, and I'm loading all the environment files. I'm creating a fast API application, just handling some costs. This is not very important. I'm having one. No, actually, it is important. Otherwise, same sources you are running on the same system, it is going to cause you issues. But don't think too much about it. I'm having my DB, and here I'm having some patenting models like question answer request, question response, cipher request. And then if I come here to my health, this is basically telling whether the health of my API is fine, whether it is running or not. So I will up the service now and I will show you. But the main thing here is ask. Okay, so ask will take my question. It is taking the question. Question should be in the question response format, and it is going to embed the question and find top के most relevant graph nodes using vector search. ठीक है, क्वेश्चन का एम्बेडिंग निकालो और उसको ग्राफ के सारे नोड्स के एम्बेडिंग के साथ कंपेयर करो. जो भी नोड सबसे ज्यादा रेलेवेंट होगा, यू गेट दोस टॉप के नोड्स. Okay, once you get those top k nodes, I want to traverse and find the neighbors of those top k nodes. So I will traverse each node's neighborhood up to given number of hops. Hops matlab how many neighbors you want to take. Okay, so if this is one node, this is another node, this is another node, and these are joined like this. Okay, so if this is our node of concern, then if I do one hop, I will come here. If I do two hops, then I will come here. Okay, so how many hops I want to do, that is what is being asked here. So normally you can do hops 2 or 3 or whatever. If you do too many hops, then your context will become huge. Okay, then assemble the subgraph as structured text content. What is this subgraph? Okay, this is my node plus neighbors of the node. ठीक है, इन सब को जोड़ के I will create one text, and this text will be given to the LLM. Okay, so that is the whole thing that is happening here. Then I will call the GPT model to generate a natural language answer from that context. So LLM ko we will give the context, we will give the question, and it will generate the answer. So this is the function that will do the entire process. If I go inside this function, you will see it is broken down into some pieces. Like it will take the question, it will take the database, it will take top k, how many hops. Okay, so it will answer a question about Bollywood question using full graph RAG pipeline. So first thing it will do is it will get the relevant nodes. So this function is responsible for that. I will not go inside that to show you, but or I will do that. But first, let us see high level. First, I will get the relevant nodes. If relevant nodes are not there, then I will return saying that I'm not able to find anything. Say for example, your database is about Bollywood, but someone is asking about maybe some finance. So none of the nodes are going to match. So we will return to the user saying that we cannot find any information about your query. But once we find the relevant nodes, then we are going to retrieve the subgraph. Okay, so we are going to traverse those graphs given number of levels, which is given by hops here, and we'll get the block. And once we have the block, we will convert that block to text. So we will have some function here which will be we will retrieve subgraph, and then we will convert the subgraph to context. So this function is nothing but it is converting my nodes to text, and this is getting the neighbors. Okay, or you can say this is the graph traversal, and this is my subgraph to context. Okay, and after that we are generating the answer. So generating the answer में क्या करेंगे, हमारे पास एक LLM होगा. LLM को we will give the prompt saying that based on the Bollywood knowledge graph data, please answer the question from the given context. This is our typical RAG prompt, that you are a helpful assistant who is going to answer questions on Bollywood knowledge. You will be given a question, and you will be given some context. Please provide a clear and accurate answer based on the information above, and I will pass that to my GPT model. Here again I have used hard-coded GPT, but you can use some abstraction like क्या नाम है उसका, नाम मैं भूल गया, Open Router. You can use Open Router, so you can switch between Claude or GPT or Gemini, whichever one you want, whenever you want, and it will not be, your code will not be tied to GPT. In my case, I have done that, so my syntax is all about OpenAI. But you can create one abstraction. I should have created one LLM class, and from those LLM class, I should have done this generate answer. But ठीक है, demonstration के लिए है. सारा best practice मैंने भी follow नहीं किया, so that you can excuse me for that. So we are generating the answer. This generate answer will go back as a Pydantic schema to the API response. ठीक है, तो ये graph RAG answer में आएंगे यहाँ पे. तो जो भी यहाँ पे रिजल्ट कहाँ गए हम लोग, ग्राफ रैग आंसर API में यहाँ पे. ओके, सो दिस व्हाटएवर रिजल्ट विल कम, दिस रिजल्ट को हम लोग वी विल पार्स दिस and we will return it as per the question response schema that we have defined using Pydantic. Okay, so similarly you will do search also. Search will just take a node and it will return the adjacent nodes. That is not RAG. You can try that out separately. We will not do that today. Already we are over time, but my main thing was to show you this ask thing. So now let me just run the service, and then let us see a quick demo, 5 minutes, then we will close. Okay, so let me go back. So API चलाने के लिए क्या करना पड़ेगा? You can just simply do Docker Compose up, but I have not done that. So let me run the services. I will do fast API, nahi, UVCon. So I will run my UVCon. Address is already in use. अरे यार, some other project is actually taking that up. Let me अपना चाय टपरी backend चल रहा है. ठीक है, I have killed that. Hopefully now it will work. Main could not import main. Why? Error loading SGI app. Import main data. Main में है तो go inside SRC only. क्या हो गया? UV can't running. UI भी चला देते हैं. Stop it. Streamlit is also running here, so we can run our Streamlit. Let me close everything. I think because of that it is causing confusion. Let me close it. Open another one. Here, let me open the Streamlit. Install file does not exist. CD src. Chal ja bhai. Guys, just give me 1 second. I think there is some issue. It was working fine. So this is our front end, and here you will be able to ask some question. Okay, whatever question you want, like who was the main actor in the movie? कुछ होता है. You can ask some question here, and this question will trigger my entire pipeline. But for some reason the backend is not running, so if we run it, we will get some error. So let me just see why this backend is not running. What is the issue? Error loading ASCII app could not import main. क्यों भाई? main.py तो है यहाँ पे. main नहीं है क्या? app.py है, api.py है. We'll see. Sorry. Sorry. Main function का नाम नहीं था, function का नाम था API. That's why it was not working. So if I go to my docs here, okay, this is my doc, and you will see here I'm having something called as ask. So here I'm having my parameters. I will try it out. I built it using Fast API. So which films did Amir Khan and AR Rahman work on together? Okay, which films did Amir Khan and AR Rahman work on together? So what will happen here? I will go and I will look for all the nodes in which I'm having Amir Khan. Okay, then I will get all the nodes of AR Rahman. Okay, and I will pass all that information to the LLM. So LLM will know about all the movies of Amir Khan. It will know about all the movies of AR Rahman. Okay, and then LLM will figure out which is the intersection between them. Okay, so that is the whole idea. So if I run this, if my API is not out of money, then this should work. 200 आजा, 200 नहीं आया. No client statement, invalid import expected create. क्या हो गया? The service not running. 27.0.1 connection refused. API error, no client error. 500 internal server error. This is my API. 404 not found. Why? Simulate is working. Database is also running. For TEDx, Bollywood graph rack. This is also working. 7474. Why am I getting 500? 500 internal error. Guys, I will see it. Okay, I will see it and upload it. But ideally, you should get some response here. When I run this, it should give me that the common movies was so and so. I will have to debug what is happening. It was working fine. I did not make any changes, but please check the API connect. Guys, just give me 2 minutes. If we are able to figure out fine, otherwise close it here. If I do my health check is working fine. You can see it is giving me that there are 108 node counts, so that is fine. But there is some issue. I think somewhere I made any change. Just give me 2 minutes. Otherwise, we will close it. Late, I know, but I would like this to work. कहीं पे query में problem हो गया है. Somewhere I think I made. कहाँ पे query बन रहा है? I think there is some issue in the query. Just 1 second. ये देखो यहाँ पे कुछ एक extra F unnecessary यहाँ पे था. You can see. Okay, so it was I think while explaining I just put that mistype. I compared it with the upstream code and I got it. Okay, so now if I run this, chal ja bhai, please chal jao. 200. Yes. Okay, so you can see here quickly what is the question. Which films did Amir Khan and AR Rahman work on together? So answer is Amir Khan and AR Rahman worked together in the following films: Lagan and Gajni. Okay, so what are the nodes that were retrieved? So you are getting, if you look at the schema of what I'm returning the question, answer, and retrieve node also. So it is giving me information about Amir Khan Productions. Okay, because Amir Khan Productions is the production house of Amir Khan, so it is matching. I'm also getting Amir Khan. Okay, and then I'm also getting Filmfare Best Actor Amir Khan 209 for some reason, because that is there. And there might be some other nodes also. Here I might be filtering. So we will get some nodes for AR Rahman also. Okay, so we will give all these nodes as text, all the nodes of AR Rahman as text, and finally there will be a context. So this context also I'm truncating So this context will be much bigger. But here I'm having entity. So entity is Amir Khan production and Amir Khan, which movie they acted in. Okay, so here you will see Lagan. Okay, and there is a information. You will go to Lagan, and for Lagan we will see that who is the music composer. Okay, so you will see somewhere music composer A.R. Rahman composed music for Lagan. So what happened here? I had Amir Khan. From Amir Khan I went to Lagan, and Lagan ka neighbor tha A.R. Rahman because composed music. Okay, so that way we got the connection that Amir Khan and A.R. Rahman have worked together. Now this might be correct, this might be wrong, because there might be other movies also. Two movies are identified, which is Lagan and Ghazni, but it might be possible that there are more movies in which they have worked together, which it was not able to get. So that is the LLM evaluation problem. Okay, that will be LLM evaluation problem, where LLM is not giving correct answer or LLM is not getting correct question, correct retrieved context. So that is a separate subject. How do you evaluate the LLM? But at least for now, whatever thing we discussed and we have built, it is finally working. So you can clone this code and you can put your own API key, and you should be able to play around with this. So that's all for today's discussion. We will close our discussion now, and I hope you guys got some idea about RAG, graph RAG, what problem it solves, how to run it, how to structure the project, and how to run it, right? So if you clone the project, you will get all the details here. Okay, you can read about every single thing in the README file. I think I have a project walkthrough also. You can read this project walkthrough also. This project walkthrough will give you all the concepts, not just the project related, but what are the concepts that are used. And you can also go and look at this Cypher practice file. So this will give you some practice on working with Cypher. So there are a lot of queries here. After we have entered the data, you can do some exploratory data analysis. You can try to write some queries. So this will make you a little bit more comfortable with graph databases. Okay, and Neo4j is not the only graph database. There are others also. NetworkX is there, which can run locally. But Neo4j is the most popular one. That's why I chose that. So please play around with this, clone this graph, and that's all for today's discussion. We will, if anyone has any questions, you can ask. Otherwise, I will stop the recording now. Let me stop the recording.